It is showtime, yes. So just have a very short announcement concerning the photographs on the back wall there. If you haven't looked at them yet and you've been to previous meetings, it'll be a treat through history for you. So these have been put up to be enjoyed, but as a bonus, at the end of this meeting, if you would like to have one as a souvenir, and it doesn't have to have your own picture in it, you can have it as a souvenir to take home, and it's all for you. So, yes.
It doesn't have to be one. Take more than one.
It does not have to be one.
In LPEG, it would be,
Yes.
count 0.
Yes, okay. So, incidentally, I'm supposed to say who I am, so I'm Michael Dube. I'm pleased to be here at this TUG meeting. I'm not sure how many I've been to, but it's definitely in double digits. So, and I must say, this one is, as with so many of the others, has been just a true delight. And I would like to thank the organizers who have put this together. We are here on the last day, and it's been wonderful so far. I'm sure it will continue, and don't forget there's a dinner tonight. So for people who are watching online, sorry, it's too bad, but you'll have to come to the next TUG meeting in Paris. So, okay, so our timing is pretty good. Here's our program for this morning. We will start in 2 minutes, I guess. So I'll give you a chance to finish up your coffee, and we'll be able to get going.
The photographs are also available on the website, and the credentials and whatnot are there. tug.chronicles.endeavorhouse.org.
Aha, yes. For those who are here who can read the backboard, you can also get the photos online. So, you know, some people will be logging in from the outside, so I don't want to start till, 9 o'clock. We got a little off schedule yesterday, and it sort of concerned me a little bit.
Front, left. Front, left. Front, right. Front, left.
And then, yes, go ahead.
Okay, you'll leave this on for while I make the announcement. Is that okay? Oh, okay, that's good. Okay, so it's time to start. So we'll have our first talk of the day. So our first presenters are KV Rajeesh and CV Radhakrishnan, and they will be talking on Malayalam content 2.
Hello, welcome to the TUG 2026 presentation about digitally archiving Malayalam text. This is a sequel to the talk delivered by CVR at TUG 2025 last year. Since then, we have considerably reworked the workflow to make it simpler and more efficient. I would like to provide an update to the workflow in this talk. The previous workflow was a bit contrived. It involved using LaTeX to produce a special kind of PDF, which is not suitable for immediate user consumption because it only contains the hierarchically structured XML code. From this PDF, the text was extracted and transformed to produce an XML document, which involves quite a bit of manual steps as well as expertise. This workflow was developed more than 15 years ago, and then Tech4ST was not capable of processing Unicode text for complex scripts. But in the last few years, thanks to the LaTeX and ZTech engines, as well as Mikhail Hovtik's works, Tech4ST is now fully capable of supporting Unicode text as well as complex scripts like Malayalam. So we wanted to make use of the native capabilities and strengths of Tech4ST to process LaTeX sources. In this workflow, the immediate output is in HTML, not XML. The difficulty in creating validated strict XML directly from LaTeX is multifold. First of all, Tech is quite macro heavy, and authors may use all kinds of complicated macros. And secondly, LaTeX output is a visual output suitable for printing or reading on screen. It does not generate a structured data. XML being structured data, creating such kind of output directly from LaTeX is quite complicated and at times error-prone. Crucially, our volunteers who are also less skilled in XML technologies at times struggle with fixing the parse error in XML or its structure. So we wanted to separate the concerns of the lesser knowledgeable workforce, volunteer workforce at Sayana Foundation, to work with LaTeX sources. They can compile the sources, they can fix the compilation errors, and the immediate output is in HTML, which gives immediate visual feedback so that the volunteer can check the output, verify, and correct the sources if needed, and repeat the cycle. Once the HTML is verified, then the scarce limited number of expert volunteers can then work on the next part, which is to produce XML from this HTML. So the new workflow involves compiling LaTeX sources directly using Tech4ST, which produces a semantic HTML. This semantic HTML can then be converted to XHTML, which is similar to XML. From this XHTML, any kind of structured schema XML can be generated using XML processing tools such as XSLT or DOM or Saxon, etc. This helps us to separate the concerns of limited expertise versus complexity. HTML5 is quite suitable for our workflow, firstly because it provides immediate visual feedback. Secondly, LaTeX structures have equivalent mapping to XHTML, semantic HTML. For example, /section can be directly mapped to the section tag, or text IT, for instance, can be directly translated to the I tag, or a span tag with class italic, which can then use a CSS for rendering. Most importantly, Tech4ST can generate mathml directly from LaTeX sources. Tech4ST has been in our production use since many years. It's battle tested, and it has excellent support for standard LaTeX packages and macros. In addition, the HTML output is also quite forgiving, because if you miss to close a tag, it could still be rendered correctly by web browsers, but if you miss to close a tag in XML, it's a parser. It's very easy to convert semantic HTML into XHTML. Once we have the XHTML, then any standard XML toolchain should be able to produce a required XML schema. TUG works in 3 independent but coordinated steps. First step is to compile the LaTeX sources using TUG4ST, which loads the TUG4ST.sty package that redefines most of the macros, and in its place, it injects special anchors to the DVI output. Once the compilation is over, these special anchors can be extracted from DVI and replace it with XML, HTML, or MathML tags. The final stage is run only if you need to extract graphics, or if you need to split the output file by chapter, sections, etc. The real advantage of using TUG4ST is that it uses a real tech engine such as PDFtech, UTFpatgen, or ZTech. So it processes all the macros as if a PDF output is being generated. TUG4ST can convert standard LaTeX commands to equivalent semantic HTML. Sometimes if you need to customize the output, the way to do it is to use the configure command. For example, let's convert the /section command in LaTeX to an equivalent semantic HTML section tag. Use the configure section command, which takes 4 arguments. The first 2, hcode section sec level 2 and hcode closing tag section, can be used to add specified code just before the start of the section block and after the entire section content is over. The last 2 arguments here in the example, hcode h2 and closing h2 tags, can be used to add XML or HTML tags before the section title and after the section title. Once TUG4ST runs with this configuration, it will produce the equivalent output that you can see on the right hand side. MathML generation is straightforward with TUG4ST. For example, if we have an inline math equation a plus b the whole square, simply compile it using make4st with the option mathml. It will produce mathml output as displayed below, including the math class for the operators and delimiters. The second challenge we had with digitizing Malayalam text at Sayana Foundation is we have volunteers with varying levels of expertise. The lesser skilled volunteers find it difficult to work with XML and fix its errors. Instead, they work with LaTeX sources, which they are quite familiar with, and they standardize the coding into strict predefined templates so that we use equivalent semantic environments, not just formatting commands such as vspace or textpf. And using TUG4ST, the sources are compiled into HTML from which they can get immediate visual feedback and correct the sources if necessary. This process is repeated until the generated HTML is satisfactory and correct. Once that HTML is created, then the scarce expert volunteers can focus on the XML generation part and fix any errors. And this is where the domain experts like linguists also come into picture, where they can do named entity recognition, linking, critical apparatus, or XML schema validation, etc. This decouples the processing stage into varying levels of expertise. and relieves the expert volunteers from the mundane tasks. We have also built an automated pipeline, which is basically a makefile that bundles 3 different steps. First step is to compile the input source file using Tech4ST with the option mathml, HTML, and HTML5. This produces an HTML5 document, which needs to be converted into XHTML with proper opening and closing tags. For this purpose, we use the command line utility tidy. Once tidy runs through this input HTML, we get a strict XHTML, which can then be transformed into desired XML schema such as TEI XML or NLM or JATS by using XSLT-proc or Saxon or other tools. We have a case study of Kerala Paniniyam, which is an authoritative Malayalam grammar text published by Sayana Foundation a few years ago in PDF format. In the last year, we also worked to generate the HTML and XML format of it using the new workflow. We have also processed a number of articles, books, poetry, etc. using the new workflow, and those are available on the Sayana website. One particular stage of XML generation has to do with the domain expertise. For example, if we have an archival document which requires enriching with additional semantic information such as named entity recognition and linking, or critical apparatus, for example, the apparatus, lemma, and reading, this can be added during the HTML to XML conversion process. In addition, strict schema validation can also be automatically introduced, for example, using XML link. So we automate it as much as possible, but the meaningful part is still left with the experts and domain experts. Compare the old workflow with the new. Previous workflow has been using LaTeX to create a specialized PDF, which is completely removed to use HTML produced by Tech4ST. And in the previous workflow, all these steps require high level of skill, but now we have separated the first part of generating HTML from LaTeX sources can be run by much lesser skilled volunteers. The XML generation was also a manual process in the previous workflow, which is completely automated using XSLT processing in the new workflow. And the previous workflow did not support MathML, so we were unable to create XML and HTML of the 15th century mathematical treatise called UTFpatgen, which Sayana Foundation published a few years ago in PDF format. But with the new capabilities, we will be able to generate the XML and HTML version 2. Since the previous workflow was complicated and contrived, only few people were able to work with it, but with the new workflow, a lot more volunteers can work with it. The major challenges implementing the new workflow was the initial configuration of Tech4ST. An example was shown earlier, how to configure the section command. But it is much easier than writing LaTeX macros, for instance. And creating XSLT programs to ensure strict HTML generation was the initial challenge. And balancing this complexity of the configuration versus the lesser knowledgeable volunteers who work with LaTeX sources to strictly use specified templates was another challenge. What we learned is that a limited set of LaTeX commands in strict semantic environments using a LaTeX template greatly helped. And HTML5 is quite robust, forgiving, and human readable, close to XML format that could act as a bridge between LaTeX sources and XML. And lesser knowledgeable volunteers are familiar with LaTeX and they're familiar with LaTeX errors, they know how to fix those errors. So let them fail gracefully in that stage is much easier and productive than let them also fix the generated XML errors. This whole project is open source and it is driven by the community. Source code is available in GitLab under the organization SAYAGNA. Project name is archiving. All the code and documentation is licensed under LaTeX project license or equivalent free software license. The documentation is also included in the repository, which helps anybody interested to jumpstart. This workflow is language agnostic, so it could be extended for other Indian languages, Dravidian languages like Tamil, Telugu, Kannada, or other Indic languages like Hindi. With that, I would like to thank the organizers of the Tech Users Group Conference 2026, and I welcome any questions or discussions. Thank you very much.
We seem to have no signal on here.
That's fine, I just gotta turn it back on.
Okay, we're on. Oh, thanks so much for that really interesting presentation. We have a few moments for questions if anybody has them. Yeah. Yes.
Okay. Hi, I'm Marcel Krüger. It was a very interesting presentation. Thank you very much. One question I was wondering about, we now have a lot of the tagging support, which actually adds a lot of structured information to PDF files. Did you consider if it would now actually be possible to extract that directly as XML from the PDF and basically skip text for HT for these kind of use cases?
No, Marcel, we have not considered extracting XML tags or the accessibility tags from PDF and using that to generate XML. Maybe it's something that could be considered, but for us, TechForest works quite well.
Thank you.
Hi, this is Pavneet. I was curious that when you talked about segregating the workflow for lesser skilled and more expert users, did you design the workflow around the skill set of those two populations, or did you find people, assuming that there was a lesser skilled population of workers that you wanted to use, and you were trying to find those that fit the bill?
The Sayana Foundation is a volunteer-driven organization who is involved in archiving Malayalam content, and we have, as I mentioned in the presentation, a number of people who are not XML experts. Since it's a volunteer workforce, people come and people go. So we had to adapt our workflow based on the availability of the volunteer workforce. So yeah, it's the latter, that we design the workflow, redesign the new workflow so that it matches the skill set of the workforce. And we found it also quite beneficial for the expert workforce who doesn't have to be bothered about the nitty-gritty details or the earlier part of the processing. They can focus on the important, such as fixing XML errors, or involve linguists or language experts who could work on enriching the XML part.
Okay.
Hi, Rajeesh. It's Carl. I just wondered how big the project is, how many lower skilled volunteers there are, how many expert volunteers there are, how many documents you've archived approximately, Just wondering.
Okay. The question to the first part, the number of workforce or the volunteers probably could be counted on a single hand, including both the non-expert and the expert volunteers. A couple of the expert volunteers, one of them is CBR, the other one is Ashok Kumar. And then we have a few people who work on LaTeX to HTML generation and pre-processing part. So far, we have, to my knowledge, which could be obsolete by now, we have processed more than 10,000 pages of text, including the old workflow and the new workflow. And we published a dictionary for Malayalam called Shabdatharavali, which was a huge community effort. I think it was during the COVID period where a lot of people were able to find time to contribute this and the grammatical text. Plus, we also wanted to generate the XML format of UTFpatgen, which is a 16th century treatise on mathematics and astronomy, which discussed the fundamentals of calculus at least a century before Newton and Leibniz. We produced the PDF format, but was not able to produce the HTML and XML version because of missing math ML capability. So it's a future project. All these documents, there are a few English text as well, such as B.R. Ambedkar's discourses on caste in Indian context, plus a few short stories by Maupassant, in addition to the Malayalam content. It's all available on the sayana.org website.
Okay, well, thank you for answering those questions. And are we about ready to proceed on? Okay, thank you again.
Thank you very much.
Is this microphone on?
No.
Oh.
As usual.
So
If you just speak up, we can probably hear you in the room, and then you don't need
Yeah.
yeah, it should be
It's all right.
I think we should
I-
wait for 9:30.
Yeah.
Next talk.
Yeah, so as you see, the next talk's at 9:30. People may tune in particularly to see this talk, so it would be really cruel to them to start early. So rather than to have unhappy users, we'll give you a moment to have a little pause or even grab a little bit of coffee at the back, but we will start promptly at 9:30. Did you all hear that? Food outside a little bit if you want to grab a late breakfast.
Oh wait, no, that's the
Oh. So now I'm going to have to go out and grab everybody to get them back in at 9:29, but I guess it's okay. 9:24, so it's 5 minutes. It's good. I guess I'm talking to the world here. A coffee break is delightful, but all good things come to an end at some point.
Okay, we're set to go.
Okay, so we're ready for the next talk. Our presenters are Ondřej Metelka and Petr Sojka, and they're going to be talking about UTFpatgen.
Hello everyone and warm welcome from Brno. My name is Ondřej Metelka and today I will be presenting on my behalf and on behalf of my co-author Petr Sojka about UTFpatgen, hyphenation without borders. Let me start with a brief overview of the presentation. The first thing will be an introduction where I will talk about the context of the article. Then I will move to motivation part. The third part is about the UTFpatgen itself, where I will talk about the implementation, the improvements we did, and the integration into the landscape. Then we will move to the evaluation part, where we will introduce the experiment and the results we observed. And finally, there will be a conclusion part where I will summarize the outcomes of the article. Hyphenation is a technique used in typography to split words at the ends of lines. The editors use it to achieve nicer layout of the text with block-like alignment or consistent spacing. It becomes even more relevant in paragraphs that are really tight, such occur in smartphone screens, for instance. Hyphenation software is embedded also in text editors or web browsers. The most widely used approach to the word hyphenation problem is through hyphenation patterns. These can be generated from dictionaries by the Patgen program. And the example below shows an entry from such hyphenation dictionary. This one is Merriam-Webster. And the hyphenation itself can be seen as the first thing on the second line. Few words about Patgen, which I mentioned on the slide before. Patgen stands as an abbreviation for Pattern Generation Program. The first version comes already from 1983. However, there were some updates, and the latest version 2.4 is from 2020. It is written in web literate programming language, which is a combination of the Pascal programming language and plaintext documentation. The core idea of Patgen's algorithm is to iteratively loop through the input dictionary and to collect candidate patterns. These patterns are then evaluated with their frequencies and the user-specified acceptance criteria. The program uses mixed command line-based and file-based approach. That means all inputs and outputs are specified through files, and additionally, the program prompts for numeric parameters at runtime. Here you can see a high-level scheme of the algorithm. In the bottom left corner, there are 3 input files: the dictionary, which contains the hyphenated words, the pattern file, where an initial set of hyphenation patterns can be specified, and the translate file, which contains a character mapping. That means the lowercase and uppercase characters. The output file in the top left corner is also provided to Patgen, but it is used as an output parameter for storing the generated patterns. We can divide the execution into 3 phases. In the preparation phase, the initial patterns are parsed, the character mapping from translate file is parsed, and the user specifies the range of hyphenation levels. The pattern generation phase contains the dictionary loop itself. The user provides the range of pattern lengths and the acceptance weights. These are used to evaluate the candidate patterns and select those that will be part of the persistent set. This is repeated until all the levels were processed. The output phase then writes all the persistent patterns into the output file. The user may specify that they want to hyphenate the dictionary as well. In that case, another file called pathtmp is created, and this contains the hyphenated dictionary. Although the algorithm is quite efficient, there are several technical limitations that make the pattern generation impossible in some cases. Firstly, Patgen posed hard bounds on the input dictionary. First and foremost, it allows only a certain number of lowercase characters to occur in the dictionary, and additionally, it limits the word length to 50. The processing capabilities are limited as well, with only 9 hyphenation levels and patterns to the length of at most 15 to be generated. And lastly, there is some technical debt, which stems from the age of the program. For instance, the modularity is quite low, which makes the maintainability and testability even lower. As a consequence, Patgen is practically unusable for some use cases. Firstly, when processing data from the web, there is a chance that we will encounter more distinct characters than Patgen allows. With larger input alphabets, we would be able to explore the field of universal patterns. This means joining several languages into one set of patterns and consequently saving some space. Secondly, we run into problems when the hyphenation dictionary contains words that are too long. This can happen, for instance, in German, which uses compounds quite often. With these issues in mind, we started working on a new hyphenation program that we call UTFpatgen. We chose the CWeb language for implementation. CWeb is a successor to Web, which still follows the literate programming paradigm, but switches Pascal for C. The reason is that C offers few features that we find useful, for instance, the dynamic memory allocation. We managed to implement the algorithm almost identically to Patgen with just 3 exceptions. Firstly, we changed the character mapping so that the alphabet size is increased. Then we adjusted the weights and levels representation so that the scope of these parameters is increased as well. Finally, as mentioned before, we use dynamic memory management so that the static structure sizes of Patgen are no longer an issue. We also performed several general refactoring tasks, such as variable localization, grouping of related variables, function decomposition, and we eliminated the go-to statements which are deemed harmful. Let me now talk about the character mapping, which was the biggest adjustment we did to the Patgen algorithm. We faced the challenge that the algorithm was designed to work with just single byte characters, which would leave us with only 256 distinct characters in the input alphabet. So we proposed a method that translates each character into a uniquely decodable sequence of bytes. It is a two-step procedure. Firstly, we assign each character a unique index from 1 to n, and then we convert the indices into sequences. You can see an example mapping in the figure on the right. We start by assigning only single level sequences and add another byte only when the smaller ranges as fully exhausted. Thanks to this trick, we keep the mapping compact and memory efficient. We can also easily distinguish the sequence boundaries so that we are able to process only those positions that correspond to places between original characters. We draw inspiration from the UTF-8 character encoding, which also uses variable byte lengths, hence the name UTFpatgen. To achieve even bigger space efficiency, we can sort the characters in the translate file by their frequencies in the dictionary, so that the most frequent ones get the shortest sequences. This slide shows the compilation process of the program. The CWeb language allows us to generate not only the binary itself, but also a PDF report that contains the formatted documentation sections. Both targets require utilities from the TechLab distribution. CTAN extracts the C-source code from the CWeb file, and CWeave transforms the file into a plain text document. From those points, the compilation is standard for the respective languages. Here, we summarize the improvements of our implementation over Patgen. In several aspects, we remove the bounds completely, see alphabet size, input word length, and input letter size, while in others, such as hyphenation levels, weights, and pattern lengths, we increase the scope significantly. Newly, the user does not need to reconfigure the structure sizes if their application does not fit the default setting. This is done dynamically at runtime. We also drop the platform dependency in the case of acceptance weights. Although it may mean that the value range is smaller now, it is still sufficient in our opinion. We strived for maximal interface compatibility with Patgen. Besides the hyphenation level and weights representation, the two programs are completely interchangeable, and even this difference can be solved by a simple command line translation. UTFpatgen will appear in the TechLab distribution next year, and the source code repository is already published under the MIT license on CTAN and GitHub. Now, the presentation moves to the evaluation part. We ran UTFpatgen with several configurations and observed its behavior compared to Patgen. As the base for experimentation, we created the HIFbench collection of hyphenation dictionaries. HIFbench comprises 18 datasets in total from 15 languages, including non-Latin scripted languages such as Russian and Ukrainian, which use the Cyrillic alphabet, Modern Greek, and Thai. The data come from various sources of different quality. The collection contains datasets created by Scraping Wiktionary, as well as polished academic dictionaries. The benchmark also comes with multiple parameter profiles. These are configurations of input parameters, such as the number of levels, the pattern lengths, and the acceptance weights. The variables we observed fall into two categories. The correctness variables check the algorithm outputs against the outputs of Patgen, and the performance variables compare the two programs in terms of execution time and memory consumption. The results were rather satisfying. The test did not exploit any discrepancies between the implementations, and we were able to process a joint HIFbench dictionary with over 300 characters. The performance measures dropped as expected, but the relative change was acceptable. Both execution times and consumed memory exhibited less than 3 times worse over Patgen, which we deem an okay trade-off for UTFpatgen's flexibility. It is important to note that the parameter profiles played an important role in the observed ratios as well. This final slide concludes the presentation. We introduced UTFpatgen, a program for hyphenation without borders. UTFpatgen extends the original Patgen program in several ways. Thanks to improved character mapping, we are able to process dictionaries with arbitrarily sized alphabets. Further adjustments to the memory management and parameter representation allowed us to increase the flexibility of the program. And lastly, Our implementation underwent a refactoring phase for better testability and maintainability. We evaluated UTFpatgen on the HIFbench collection of hyphenation datasets. We did not find any algorithm flaws and observed only a modest performance drop compared to Patgen. The integration into the open source landscape is ongoing, with the source code repository freely accessible and the program waiting for inclusion in TechLab 2027. And that was all from me. Thanks for listening and have a nice rest of the conference.
Thanks so much for this nice talk. Oh, the microphone's working again, I guess. This a microphone with artificial intelligence. Who would have believed it? It decides that I'm okay now. Thanks so much for that fine talk. We have a few moments for questions if we have any from the audience.
Since you are accepting I'm Marcel Krüger. Since you are accepting Unicode input, what is your definition of a character in your character splitting?
Do you mean character in the input text?
Yes.
As it's mentioned, it can be an Unicode character, and if I'm not mistaken, it should be just UTF-8 encoded character.
So a Unicode code point, basically.
Yes.
Yeah.
Yes, it is. Similarly, as ZTech accepts UTF-8 input, UTFpatgen accepts any UTF-8 character.
Did you consider how it would affect the pattern generation if instead of looking at Unicode code points, you would look at grapheme clusters to avoid having these separate characters for combining stuff?
It seems that Max is speaking, but we do not hear anything.
Oh, I did hear the question, but could you please repeat it once more?
Sure. I was wondering how pattern generation would change if instead of Unicode code points, grapheme clusters would be considered as input units.
What was the thing that should be instead of UTF-8?
Unicode grapheme clusters, so that you combining characters.
I'm not so proficient in how this works on the byte level, but I guess as long as these clusters are not hyphenated anywhere in the data, like there is no hyphen between those three parts or two parts of the character, then it should work fine. Or it will treat them as two characters or three characters or whatever the number is.
Okay. Any further questions?
Is Peter muted?
Yes, that's what I was going to say.
Hello?
This is
Do you hear
Barbara
me?
Beaton. The problem that I found particularly annoying is this.
I don't hear Max.
Just hold that one.
Sorry about that.
Try now.
A problem that I found particularly annoying is the fact that compound words from chemistry and other medical terms, there are proper hyphenations or allowable hyphenations in many places, but the preferred ones are between the compounds. And it's impossible with the original PatGen to distinguish between them. Is this something that can be handled with the improved PatGen?
You can somehow assign weights to hyphenation points that you want to prefer. So in a sense, that should be possible. But I think it's possible also in the old PatGen.
Yes.
Maybe just the range of weights is smaller.
I haven't found a way to distinguish the weighting of the different hyphenation points.
Yes, one cannot by now, but as with increased number of levels, you may have patterns that in LaTeX distinguishes between results achieved by levels 1 to 4 or levels up to 16, let's say, and this way you may have in one pattern set different hyphenation points encoded, and that's due to the increased number of levels. And similar technique might be now used for multi-language patterns and other obscure ways how to encode language information for words in patterns.
Is that good, or do you want me to?
I'll be in touch. Thank you.
Wow.
That's
Sorry,
actually
I
a
do not
pleasure, not a
hear
threat.
I'll take that.
anything now.
Are there further questions? Nope.
Sorry about
You have
that.
to be loud voice, I'm afraid, Charles.
Hi, Charles Statz. You mentioned that the UTFpatgen has slightly lower performance than the original, and
I don't hear anything now.
I can hear clearly, so maybe
Okay.
I can answer the question.
Okay, so anyway, I mean, from a practical matter, I'm guessing that's totally, the performance difference is pretty much irrelevant, but I am curious, is the difference just an expected result of using a more complex setup, or, you know, having more options that take up more space, or is it is it a result of the older one having been around longer and been subject to more optimization?
My opinion is that, for instance, the dynamic memory management may cause a bit of slowdown, as opposed to the static sizes, which are just really easy to compile and optimize by the compilers. But yeah, there might be some super optimizations in the old code as well. Yep, you're welcome.
Are there any other questions? Besides, will this microphone work? Okay, we seem to be good. So let's thank our speakers again. It was really very pleasant.
Thank you.
Thanks.
Nice to see you again, Peter. That's it. Okay, so we'll be resuming at the top of the hour, so you have just a couple of minutes to chat.
So Barbara, I think you're talking
take that out of your way. Okay. So I'm sort of waiting to the top of the hour in case people tune in late, and they'll get you right from the beginning.
Recently
To resume. Okay, so we're ready for our next presentation. Our presenter is Didier Verna. He's speaking on quantum boundaries for last line adjustments.
Thank you very much. So this is yet another episode in my long series about the fine-tuning aspects of paragraph justification. I hope to have the series aired on Netflix at some point, but not right now.
Coming this fall.
Yeah, exactly. This time I have focused on the fine-tuning aspects of the final line of a paragraph. So I will not insult this audience by explaining what glues and boxes are. I'm supposing that it's fine. But let me just quickly restate the nice trick that the Knuth uses for the final line, for adjusting the length of the final line. So essentially, the final line in a paragraph is just like any other one. It's a sequence of boxes and glues and everything, except that at the end of the final line, there is a special glue which has no width. It has a 0 width, but it's infinitely stretchable. Okay. So this is a nice trick because when the Knuth attempts to justify the final line, it essentially doesn't need to know that the final line is a special case. So there are two different situations. If the final line of a paragraph is naturally overfull, as demonstrated on the first line here in this illustration, then it will be shrunk to the paragraph width as any other line. But in the case that the natural width of the line is below the paragraph width, then the Knuth essentially tries to adjust it to the full paragraph width as any other one, except that to do that, it needs to stretch it a lot, and all the stretching required essentially is absorbed by the infinitely stretchable glue at the end. So the net effect is that the final line actually remains at its natural width. Okay, so this is the nice trick that the algorithm uses. So this is a cool trick, but it has some drawbacks. One fairly well-known problem is that if you are in a situation like this one, where the final line is at its natural width and the other one is loose, you would prefer the final line to be stretched a little bit in order to be visually more coherent with the previous line. In other words, what you would prefer to have is something like this. Okay? This is subtle, but my whole life is devoted to nitpicking stuff like that. And yes, I do see my shrink once a week. Okay, but as we will soon discover, this is not the only problem that there is. And in fact, if you go into really conscientious typography, in other words, if you go see the shrink twice a week instead of only once, there are a number of different situations that you would also like to avoid. Oh no, the demonstration is not supposed to be happening right now. Okay, so probably I need to go to the next slide. Yeah, okay, sorry. Yeah, no problem. Okay, so there are a couple of additional aesthetic considerations that you want to take into account. And those things are also well known because Brinkhurst, for instance, talked about this years ago. So the first case that you would like to avoid is what's called runt lines, which are final lines which are extremely short. Okay, so this is actually an interesting case because it's bad for at least, in my opinion, 3 different reasons. The first one is that this final line is just in absolute terms too short to be actually really satisfactory from a purely visual point of view. The second problem there is that the final line is constituted of only one word. So you have 2 consecutive micro interruptions in the reading experience. The eye reaching the end of the one before last has to stop to go to the next line, only to find a very short thing that ends the sentence. This is also the second reason why this is bad. And on top of that, if the length of the final line is so short that it becomes the same order of magnitude as the paragraph indent, this is even worse. Okay? So this is something that you really want to avoid. And then we have the analogous situation for lines which are too long, and these are called full out lines. So here the situation is not particularly pleasing because this line is actually almost the paragraph width, but not exactly. So it gives you the impression that there was an attempt at justifying completely, but it failed, which is actually not the case. Okay? So here the situation is even more complicated to handle because you have 2 different possibilities. Well, maybe you don't have any possibilities, maybe one, but in the best case, you have 2 possibilities. You could either try to completely justify the line, it's better, but if it's also possible, you could try to shrink it in order to make a distinction between a failed attempt at justifying and something which is voluntarily too shorter than the paragraph width. Okay? So these are also aspects that we want to take into account. Okay, so in my experiments, what I did was define 2 thresholds which become additional parameters in the justification algorithm. Like, you know, we don't have so many yet, so two more is good. I'm defining the runt threshold, which is the limit at which you do not want a short line. And we have also the full out threshold, which is the limit which you want to avoid. So either you need to be below or you need to be completely justified. Okay, so in my experiments, I think that 50% of the paragraph width for the runt threshold is nice, and 5% for the full out one is also nice, but these parameters are adjustable, okay, obviously. In any case, these define two avoid zones, so to speak, which are the zones in which you absolutely do not want the final line to end, okay? All right, so before explaining how the algorithm works, I need to give you a crash course on the data structures that I'm using in my implementation of the CNUF+, because it's really different from the original implementation. It uses a set of object-oriented data structures, and so you need to get some acquaintance with those in order to understand how the rest works. So there are two sets of data structures, one for the problem domain and one for the implementation of the algorithm itself. So in terms of problem domain, what we have is an abstract class at the top of the hierarchy, which represents every kind of breakpoint there is. So these are actually typesettable items. And then, that's obvious, discretionary is a special kind of breakpoint. And then an hyphenation point is a special kind of discretionary, as done in the original system. Then a glue is also a special kind of breakpoint. And I also have a special class for, which is called EOP. Anyone? EOP? End of paragraph, obviously. So this breakpoint is instantiated once in the run of the algorithm, and it tells the algorithm this breakpoint indicates that we have reached the end of the paragraph, okay? A couple of notes about this. As you can see in my implementation of the CNUF+, penalties are not typesettable items. So you do not insert a penalty somewhere. Penalties are actually properties of every single typesettable item there is. So this gives me, this is unrelated to this talk, but it gives me the ability to fine-tune every single penalties for every glue differently, every hyphenation point differently, and stuff like that. And when I heard the previous talk, I think there's something to be done with weighting hyphenation points, which could be done extremely easily with the system. But anyway, this is not related to this talk. What's related to this talk is that, as a matter of fact, you guessed probably that in order to adjust the final line, we cannot use the trick, the original final infinitely stretchable glue trick anymore. So we need to get rid of this final glue. And actually, it's already the case in my system. I do not have a final glue in my horizontal lists because this is replaced by the special end of paragraph boundary, which I have. Okay, so this is the problem domain data structures. Now for the algorithmic data structures. So I have something which is called a boundary. A boundary represents a particular breakpoint during the run of the algorithm associated with a specific line. Okay, the beginning of the line is not represented because I don't need it, but this is in association with a beginning of a line. So a boundary contains a reference to the actual breakpoint at which we change the line. There is the minimum width, the maximum width. Any Slavic attendees in the audience? I think there is at least one. The Tsar is not what you think. Yes. In the case of the CNUF+, because I have different typesetting algorithm in my system, there is a subclass of boundary which is KP boundary, which stores additional properties related to the CNUF+ version of the paragraph justification algorithm. And as you can see, a boundary for the CNUF+ stores the fitness class of the line, the badness of the line, and the local demerits of the line as well. Again, a couple of notes. The maximum and minimum width of the line represented here obviously are not the natural ones, but they take into account the current tolerance that is set by the algorithm. Okay, so it can vary depending on your setting of the current tolerance. And so what I call the TSAR in this system is actually the acronym for Theoretical Spacing Adjustment Ratio. This is the amount of elasticity that you need to use in order to stretch or to shrink the line to the target justification width that you want to use. Okay? So far, so good? All right. So now it's time to, oh yeah, sorry, no, it's not yet time to see how it works. I have to also recall something very important, a theoretical point about the way the CNUF+ works. remember that the paragraph justification problem is essentially a single pair shortest path question in a graph of possibilities. But I insist on this. This is extremely important. We use a graph to represent the possible breakpoints and the paths from the beginning to the end of paragraph, and not a tree, because if you were to use a tree, you would completely blow the memory of your system, okay, pretty quickly, because the theoretical complexity of this is exponential. So this has an extremely important consequence. If you're using a graph as opposed to a tree, it means that the nodes or the boundaries in the representation are shared by all possible solutions. In other words, what this means is that the way you will continue going down the graph cannot depend on how you reached a point in the current path that you're pursuing, okay? If you've reached a certain position in the paragraph, the way you reached it cannot have an influence on the remaining of the solution. Otherwise, you cannot share nodes. You need to duplicate the nodes. And this actually is something which already happens for two different reasons in the original Knuth class. The first one is in the case of non-rectangular paragraphs, because if you end up on line 7 with different breakpoints, or on line 8, for instance, the lines below are not necessarily going to be of the same width, and then the solutions are going to be different. Okay? And the second reason for not sharing nodes in the graph is the fitness classes. If you have a single breakpoint with two different lines reaching it of two different fitness classes, then you cannot predict what's going to happen next, because you could be inflicted a fitness penalty, a fitness demerit, or not. So you need to remember both solutions, and so you need to duplicate nodes instead of sharing those nodes. Okay? And so as we will discover pretty quickly now, when it comes to adjusting the length of the final line in a paragraph, we need to also duplicate in some situations, but fortunately for us, not in every case. All right. So this is what I did at some point. I tried to enumerate all the possible situations you get when you want to adjust the final line of a paragraph. And if you can imagine, there is no less than 32 individual possible situations. Okay? They're all represented on this figure. What you have here, if you take this one, for instance, this represents one possible line with its minimum width given the current tolerance, its maximum width given the current tolerance, and then the natural width of the line is somewhere in the middle. Okay? So if you want to enumerate every possible case, these are all the cases in question. There are 32 of them. Fortunately for us, the treatment is not necessarily different in every situation, and sometimes you can even treat different cases the same way with a different outcome, but the algorithm will remain the same. So now we're going to see what we need to do on these specific cases. So first, there is first a whole set of cases for which you do not need any new kind of data structure to represent the line breaks. You can just reuse the original ones. So these are what I call the deterministic cases. So for instance, in those situations, as you can see, every line in those cases is too short or just the required amount to be justified to at least the runt threshold. Okay? So what I'm doing here is just reuse the classical boundaries that I already have, except that I'm going to pretend that my justification target width is not the paragraph width, but the runt threshold. So I'm computing the tsar accordingly, and I get different situations. In cases 1 and 2, the line is too short, so the tsar is going to get a badness exceeding the tolerance, and the line is going to be considered as underfull, and it will just be eliminated as a regular line by the algorithm. Okay? In case 3, there is only one possibility. The line can be extended to exactly the runt threshold, and so it will be. And in case 9, there is no choice. The line is not elastic, and it happens. This basically never happens, okay? But from a theoretical point of view, you absolutely need to handle every possible case. And so in that situation, the line is already at the only width available, and it happens to be a correct one. But that is really miraculous, okay? Okay, so deterministic cases, number 1. Number 2, it's sort of the analogous situation. So in those two situations, what you can do is adjust the line to be the full out width, okay? So I'm again computing the tsar accordingly. And in those two situations, the outcome is the same. The line is adjustable and we can use it, okay? So in case 21, the line is already fine. And in case 22, the line is shrunk to the full out width, okay? Interesting cases number 3. I'm still using the same data structure, but this time the outcome will be different. In all those situations, there is only one possibility, which would be to fully justify the final line. So I'm going to pretend to do that, but the outcome will be different. In cases 27 and 28, it works. This is the only possible solution. In cases 29, there is nothing to do. In cases 30, it also works, but not by stretching, by shrinking. And in case 31 and 32, the line will be considered overfull as as a regular line in the algorithm, and so it will be eliminated by the algorithm as before, as a regular line. Okay? So far, so good? Am I making any sense? Yeah. Okay, fine. And now this is the time when we enter the quantum world. Of course, this is just a marketing term to catch the attention, but there is still a kind of a nice analogy with quantum mechanics. I'm going to explain why. There are a number of interesting situations in which you end up having a lot of possibilities, but because those possibilities depend on the one before last line, you cannot yet make a decision, at least if you want to continue sharing the nodes in the graph, okay? And so the idea that I have here is in fact quite natural once you come to think about it. At that point in the processing, I do not know what to do. I cannot make a final decision. So let's not make a final decision. Let's carry the uncertainty as long as possible. And this is when we enter the world of quantum mechanics, because we have boundaries which are in sort of an indeterminate state. They are in multiple states at the same time, and the final state is only going to be decided once a final and actual paragraph solution is observed by the observer, okay? So this is the analogy with quantum mechanics. So in those situations, you have basically two possibilities. You can either shrink the line to the full out threshold, or you can try to attempt full paragraphs justification. So I do not want to make any decisions, so I'm keeping both possibilities. And hence the existence of this new class, which will store the full out spacing adjustment ratio, so the amount of shrinking or stretching that I need to get the full out width, and the justification spacing adjustment ratio, which is the one required to reach that point, okay? So I'm just keeping those two values around. In that situation, the tsar, the original one, because remember that this class gets a tsar. So this one is a subclass of this one, so it also gets the normal tsar. And so the regular tsar is going to be initialized to a minimum of those two values in order to remain as close as possible to the natural width of the boundary. Cases, a couple of other cases using the same class. This time, as you can see, no solution is possible. But I want to express the fact that these two cases cannot be either shrunk or stretched. So I'm keeping those two values again. And in some sense, it means that a line like this one is actually going to be both overfull and underfull. Okay, quantumly speaking, okay? It's going to be overfull with respect to the runt threshold and underfull with respect to the paragraph width, okay? Are we enjoying ourselves so far? Okay, so for a reason that I'm not going to explain, the tsar is going to be initialized to the justification adjustment ratio. I don't have time to explain why, but if you're interested, I can give you the explanation over coffee. Two additional cases where another kind of quantum boundary is required. In those situations, the cases are more complicated because for all these lines, you have a full range of possibilities plus the possibility to be fully justified. Okay, but again, remember that we want to avoid this zone. So there is a whole range of possibilities. Then we jump, quantumly speaking, to the paragraph width, okay? So again, I'm going to store that information. The minimum spacing adjustment ratio is the one which is going somewhere here. The minimum that you can do. The maximum is the maximum that you can do within this interval. And then you also have the JSAR to represent the adjustment ratio needed to reach the paragraph width. Okay? Final case, and then we can go back to our good old deterministic life. These cases use the same data structure, but the difference is that those lines cannot be fully justified. So the situation is exactly the same, except for the fact that the JSR is going to be set to nil, indicating that it is not possible to reach the full paragraph width. Okay? How am I doing with time? Extremely bad as usual. Okay, so these are all the cases. Now, in terms of sharing, let's get back to that particular problem. As you understood, in the deterministic cases, we don't have any problem because we're just reusing the old data structure. In the quantum cases, there is a problem, obviously, because at some point we have to make a decision. So I'm not going to enter into too much detail here. But let me just mention that at some point we need to duplicate the nodes, and so we need to get rid of sharing, okay? But this is going to be done at the final stage, as late as possible in the process, okay? So when we're considering an actual path, we need to fixate the state of the quantum boundaries, and in order to not disrupt the sharing of the nodes, the quantum boundaries are going to be duplicated, and the actual tsar is going to be fixated once and for all, depending on the appearance of the previous line. And that's about it, okay? And obviously, the adjustment consists in getting as close as possible to the tsar of the one before last line, given what's permitted by the quantum boundary restrictions. Is that clear, more or less? Okay. Yes, one thing extremely important, that question could be debated, again, over coffee, not right now, but there is also an implication with this algorithm, which is that when you stretch the final line, the question is whether to take into account the badness of the final line. The Knuth class takes the badness of the final line into account only when it shrinks it. But that's because it never stretches it. Okay? So in some sense, the question could be debated because stretching the final line, you want to do that in order to get something more beautiful, more coherent with the previous line. So what sense can it have to stretch the final line in order to be more beautiful, but then increase the badness because of stretching, which is a way of saying, no, this is going to be badder and badder, okay? I still think that stretching is, taking into account the stretching badness is important, and this is what I do, but this question could be debated, just not right now. Oh yeah, so now I need to get back to the, sorry. Yeah, I need to get back to the demo. Okay, so this is a demonstration of the algorithm in real time so that you can see what's going on. So at the top here, I'm going to trigger the visual clues for the two thresholds, which you can see here. Okay. So these are the runt and the full thresholds. Here, these are the sliders which allow you to adjust in real time the values for these two thresholds, and we're going to look at different situations. So I'm going to increase the full out threshold progressively, and you will see the final line shrinking in order to fit the constraints to a point where it's not possible to fit it anymore. And so another solution has to be chosen by the algorithm. And then again, it's going to happen. And this time, the only possibility was to find another solution which happens to be completely justified. Now let's do the same thing for the runt threshold. So I'm increasing the runt threshold. So this line has some elasticity, so we're able to stretch it a little bit. At some point, we can't anymore because that would exceed the tolerance. So we need to find another solution, and et cetera, et cetera. My thresholds stop at 50%, so this one is the final one. And here is yet another situation. So this is interesting because there's no elasticity on this line. So if the threshold increases, I need to find another solution. So now we're going to directly jump to yet another solution, because the final line, even though it had some elasticity, did not fit the constraints of the algorithm, and so we had to resort to another completely different solution. All right, so this, yes, okay, so that's how it works. Now, what I did was study the impact of this algorithm on the general outcome of the paragraph justification. So I did a lot of experiments. I did more than 1,000 experiments on paragraphs coming from the Moby Dick novel, and every time I run the original Knuth-Plus algorithm and my version with the final line adjustment to see the behavior and the impact on the results. So there is a number of statistic results which are, I think, worth studying. So first of all, failures. In the original case, the Knuth-Plus completely fails within the tolerance that you give it in 33 cases, which is 2.5%. Okay, so that is the cases where the original one cannot do anything. So you have to reformulate or increase the tolerance or do something sloppy or whatever. If you take into account the new parameters from the new constraints with the final line adjustment, I got only 4 additional failures, which is not a lot, okay? And again, then what you need to do is either adjust the thresholds to let the algorithm perform correctly, or maybe increase the tolerance, blah, blah, blah. Here is an example. In this case, there were actually only 2 solutions, all in all, okay? So the first one is on the left, the second one is on the right, and as you can see, these are the only 2 possibilities for this paragraph, and in both cases, the final line is the same, and it doesn't have any elasticity. The gray area represents the threshold, okay? So normally you would like the line to be at least that long, but you cannot possibly do it. So it fails in the first case, and it fails also in the second one. And we've run out of possibilities, so there is nothing that you can do here. Another interesting result is that in the vast majority of the cases, the solutions are the same in both versions of the algorithm, and that is 86%. But beware, when I say identical, I mean the breakpoints are the same. But then, even though the breakpoints are the same, the final line is going to look different because its width is going to be adjusted. Here are a number of examples. This one is a case where the original one was already satisfactory because it fell into the bounds, the 2 thresholds. Okay, so this one is at its natural width, but as it happens, the previous one is actually loose. So I don't know if you can see it, it's a bit subtle, but in my version of the algorithm, this final line has been stretched a little bit because this one is stretched, the previous one is stretched. Okay, so this is more coherent with the previous one. There are also a number of cases where the original line is not satisfactory, but yet it is adjustable. Interestingly enough, I discovered only one case of an original runt final line which could be adjusted. This is probably not surprising because runt lines are very short, so the likelihood to have enough elasticity to do something is really low. And sometimes the runt lines are not elastic at all, so there is nothing you can do, okay? I'm not going to show you this example because you wouldn't see anything. In this particular situation, which again was the only one, the line was too short by 0.66 points. And so if I were to show you the original one and the adjusted one, you wouldn't see anything on the screen, okay? So it's not worth displaying anything. Other cases where the line is originally full out. So here is an example. As you can maybe see, I'm not sure about the back of the room, but as you can see, this one is slightly full out, so it's slightly too long. So what you need to do normally is to shrink it to at least the full out width. But if you look closely, you will see here that the line is in fact shrunk more than the full out width. Why is that? Again, because the line above is tight. It's not decent, okay? So this line has some shrinking. So this line has been adapted to at least the full out width, but it's been shrunk even more to get closer to the one before. Okay? All right. And finally, adjustable overfulls going going to be shrunk, but to the full to the paragraph width. So this is 5% of the cases only. So that means that the original final line is naturally overfull. And so again, there is no point in showing you an example here, because when a line is originally overfull, what you need to do is compress it to the paragraph width. But this is exactly what the Knuth+, the original version, does. So if I were to show you both versions, you would get the same picture. Okay, so there's no point in showing anything. All right, and then more interesting situations. I think I'm out of time, but I have a deal to propose. Give me just 5 more minutes, or I will not organize TUG next year in Paris. Does that sound fair? Yeah, you're okay? By the way, I took the precaution of asking the audience and not the session chair. Well, okay. Interesting situations where the new algorithm has to come up with a different solution than the original Knuth+. And again, there are also different sub-cases within those cases. So first one, when you need to choose a different solution because it's necessary to do so. So again, in this situation, the final line doesn't have any elasticity, so there is nothing you can do. You absolutely need to find another possibility. And so the possibility that the algorithm has come up with is to stick 2 more words on the final line so that it is sufficiently wide, okay? So these amount to 75% of the cases where the situation is different, okay? Even more interesting when it chooses a different solution, but it didn't really have to, okay? And that is because of the stretching badness be taken into account. So let me explain what happens here. This line, as you can see, is perfectly okay for the original algorithm, but also for the new version, because it falls perfectly well within the bounds of the runt and the full-out threshold, okay? But what happens is the following. The line before is loose. So what we want to do is actually stretch this line to the same amount as the previous one. When I stretch the line in question, the badness of this line increases because the stretching is taken into account to compute the badness. And remember, if you know that the fitness classes in the Knuth+ are actually quite coarse. So what happens here is that the badness of the line increases, but the fitness classes do not change. So it means that the total demerits of this paragraph increase as well, to the point that it becomes greater than another solution. Is that clear? Yeah? Okay. So this is a case where the algorithm, because it has taken the badness into account, chooses another solution even though it was not a necessity, okay? Now, I have a confession to make. If I'm being completely honest, I think that this one is better than this one. But again, over coffee if you're interested, but this is not the fault of the algorithm. The reason is that the fitness classes in the Knuth+ are too coarse, and there is also another aspect which is not taken into account at all in the algorithm, which is that, for instance, it's not very nice to have a word followed by a punctuation mark as the beginning of a line. So admittedly, this is something that you would need to take into account as well. Okay, that was over coffee, actually. Fine. To conclude this, a couple of additional figures very quickly. I've computed the pruning ratio of this whole thing, which means that given the additional constraints of my algorithm, there are a number of solutions which were possible before, which become completely impossible now. The pruning ratio is actually of only 7%. I was about to say, unfortunately for us, this is not going to have any impact on the performance, because you can only figure out that the solution is impossible only at the very end of the processing, because you need to pass through the whole paragraph before making a decision. Okay, so this might be an interesting theoretical discovery, but it's not going to have any kind of impact on the algorithm itself. The average lookup depth is also to 2.11. What does this mean? It means that when my algorithm chooses a different solution than the original one, the solution in question is, in average, the third choice of the original Knuth-Plas. Okay? This is what I call the lookup depth. And so it means that the solution that I have to find is not really far away from the best one in the eyes of the Knuth-Plas. So, I mean, congrats, Don. You know, it means that it already does a pretty decent job at doing all that stuff without without entering the quantum world, right? Okay. And finally, this may be of more interest to professional publishers. I also measured the average length of the paragraphs in both cases, and I found that in 20 to 30% of the cases, when, again, the solutions are different, the new solution that is selected by my new version of the algorithm is shorter by one line, never more than one line, but one line shorter, okay? So this is probably something which is, well, it's not surprising because, again, long lines can be adjusted, and most of the time, line too short has to be, for instance, the final word has to be stuck above or something like that. So this is probably not very surprising, but it's also an incentive that you can both be better in terms of consensus typesetting and also maybe, hopefully, save some paper. Okay. And that's it. So to conclude, I guess I'm going to organize TUG in Paris after all. Mm-hmm. So as we saw, fine-tuning the final line of a paragraph is maybe not as trivial as it may seem at a first glance. Essentially because you need to you need to depart to some extent from the original algorithm, and you need to get rid of the trick, the final special glue trick. We've seen that it's not only a matter of adjusting the spacing of the line, but sometimes out of necessity or by choice, you need to come up with a completely different paragraph breaking solution. The algorithm that I have proposed is able to do both. It's able to compute new solutions and at the same time adjust the width of the final line to be closer within the authorized range to the final line. And at the same time, it's able to avoid the runt threshold and the flat threshold. The core idea, which again is not so complicated, is to carry the uncertainty until the very last minute. And that's the way you can get around the problem. And finally, experimentation has shown that in 86% of the cases, the breaking solution is actually the same, which is actually quite comforting. Runt lines, as we've seen, are also, but this is not a surprise, rarely adjustable. And also, interestingly enough, in 25% of the cases, alternative solutions chosen by the new algorithms are due to the fact that the stretching badness is taken into account. Okay? And that's all I have. Thank you.
Well, thank you so much. By the power vested in me as the person running this session, it is break time, and you are allowed to leave if you want, but you are not allowed to leave as your penalty for going over, because you must stay here for question time.
I will happily comply with that order.
Okay, that's the power vested in me. So really, if you want to sneak out, that's okay. But
I'm taking the names.
Yeah. So, where's our?
I can give you this one. If you... Oh no, I needed to answer. So.
Oh, mine. Huh. Okay. Okay. So.
Yeah. I have a question from the chat. People ask whether it plays well with microtype extensions.
Will it work with microtype extensions?
Yes.
I don't see why it wouldn't. Mm-hmm. My ultimate goal is to incorporate as many fine-tuning aspects, including autotypography and microtypography, in the core of the algorithm. So yes, this algorithm is just a matter of avoiding the thresholds. Currently, I do not have many microtypographic extensions in the core. But if for instance, you have a runt line which you cannot stretch by the usual means, But if you do some tracking or if you slightly modify the kerning, and it's sufficient to get to the run threshold, I'm extremely happy with that, obviously.
Thank you.
Eric?
So,
Or expansion.
so which, how did you override the original model? Like,
I've re-implemented everything, so I have a complete, new implementation of the original algorithm and lots of different algorithms and lots of variations which I can activate or deactivate in my platform. But this is not done in a production engine. This is done in my experimentation platform, which is a complete rewrite of everything.
and will you also be sharing that?
It's already on GitHub,
oh, okay.
so you can download it. It's one drawback for most people is that it's written in Lisp, so you have to get some. You see, Pavnit, I managed to stuck Lisp in the talk after all. But it's essentially you can use it from the Lisp REPL, but it's also a GUI. So even if you do not know anything about the underlying programming language, you can play with the sliders and everything.
Okay, thank you.
Eric and everybody, Didier's written several papers about his platform
Yeah.
and previous experiments, and they're all in TUG mode. Sorry, people online lose. You could just say that again, Didier, for this.
Yeah, I have several papers about the platform itself at the TUG conference, also at the European Lisp Symposium conference, and everything is accessible online. So if you go to GitHub, you will find the platform, and you will find probably links to the papers that I've written about the platform itself as well.
Accessible paper?
No, sorry, I meant clickable papers.
Quick question.
Yeah.
What about a what you call a full outline?
Full outline. Yeah.
That would be justified and happen to be the last line of the page. As the reader, I would expect that the paragraph would continue on the following page. But then it would be over.
Okay, I see what you mean. I'm not sure I can get an example here.
Because being non-justified is a sign that the paragraph...
Yeah, so, okay, the question you're asking, I have a extremely convenient answer for me, I mean. The question you're asking is beyond the scope of this work. The reason is that what you are talking about is two paragraphs interacting with each other. Okay, and the original algorithm does not really do that. You could probably do something related by introducing a new kind of interparagraph penalty or something. But this is still, even though it's out of the scope of my work, this is still a very interesting question, and there are a lot of different aspects that you would like to take into account. For instance, if two paragraphs without any skip in the vertical skip in the middle are so next to each other, and the final line of the previous one is tight, but the beginning of the next one is very loose. This is not really visually pleasing either, and that is the kind of stuff that you would like to be able to adjust as well. But that is not done right now.
Goes to pagination being taken into account.
Yes.
If you break a page, and the first part of the paragraph is completely irrelevant to the second part of the paragraph on the next page.
Yeah.
So, for example, the tightness of the last line and the first line shouldn't be part of the solution. But it is, of course, because you first do the paragraph and then you do the break.
And do the other one.
It's the same here.
Yeah.
You first do
Yeah.
the paragraph and then you have a page break. Surprise.
I would, along with these lines, I would also mention that there is, at least in France, I don't know in other countries, but at least in France, there is a debate among professional compositors. Some have a tendency to think that the final line of a paragraph should never be completely justified. And some others, I tend to agree with the other camp, which says that it's actually not true anymore because full justification was a problem or is a problem if you have a par indent of 0. But since a paragraph indentation of non-zero gives you the clue that a new paragraph is beginning, having the last one ending with a blank is redundant.
Okay, maybe I'll use the power vested in me.
Can I go get some coffee now?
Not till everyone else leaves.
Okay,
They deserve it
okay,
first,
fine.
right?
I'm the last
Okay.
one on the ship.
Yeah,
No
right.
problem.
You're the captain. You're on the ship. Okay.
Thank you very much again.
Right. So, but we will start at 11 o'clock. You know, people are logging in from outside and want to hear the next talk. So, out you go. Come back in. Have an extra announcement concerning lunchtime. That always gets everyone's attention.
Well, we could do it at lunchtime.
Yeah,
the announcement just before lunch.
Yeah. Well, I'll say it anyway. There's going to be an analog playground set up during the lunchtime to play with fountain pens, inks, and papers, and that sort of things. The person to see is right over here. So
you're sitting on the right side. Okay. So this is now your row. A little bit more. That's it. A little further. That's your chair. Yeah. I learned something yesterday. Not to direct, but just to guide. Sorry.
okay, so we're now ready for the next talk with everybody refreshed with coffee and little snacks. So the next talk is entitled How to Make a Good First Impression, which certainly bodes well for a conference like this. The speaker is Vincent Goulet.
Thank you, Michael. I won't use this big microphone. I'm used to project my voice. I mean, for me, it's a small audience. I usually teach to classes that are 2 or 3 times this size. It's actually my second visit in a TUG conference after the 2024 edition in Prague, and I'm here representing CTAN. Life's wonderful, eh? Probably not because I'm the most deserving person, but I was the closest one. Since I live in this country, but in Quebec City, which is a mere 4,000 kilometers to the east. It seems that there was some interest in this talk about how to make a good first impression when you submit a package to CTAN. So essentially, it would try to be sort of a guide of how to be accepted on your first upload. And as I will mention, this doesn't happen very, very often. So I'm representing CTAN. They don't seem to have a template for slides, so I just used my universities. I'm also a professor at Université Laval. Okay, so let's go. Perhaps before I start, I could just say a few words about CTAN. The objective of this conference, of this presentation, is really not to give a lot of details about CTAN. Here's just a quick outlook at the CTAN team using these nice little pictures that were made by our webmaster, Gerd. You can see that although the site is pretty important, it plays an important role in the community. It's a fairly large site. The infrastructure is remarkably complicated, but very, very few people are there to make it work. The N in CTAN means network. Originally, there were 3 nodes of CTAN, 1 in the US, 1 in the UK, and 1 in Germany. Guess which one is remaining now? Okay. There's still a place here. Normally, it should be Sachi who should come here. Sachi volunteered last year. We didn't have the opportunity really to start having him contribute to the team. We should be able to kick it off now. And I'm sure that once Gerd has made a drawing, it will represent your hair better than mine. Because it's either the beard is too dark or there is none, since the drawings are in black and white. And you can tell that the color is not exactly the right one. So this is the team. This is just to give you an idea of the volume of uploads that we're processing per month. This drawing actually you can find on the CTAN homepage. It's just that I redid it. So on average, we treat, you see around 250 to 300 uploads per month. Okay, so that's about 10 per day. Of those uploads, these are the new uploads. So we have between, it's difficult to tell on the scale here. If I just want to be in line with my abstract, I would say about 10 new uploads per month, which would give about 1 every 2 days. Okay, this varies a little bit. Okay, but this is just to give you an idea of the volume of uploads that we have to process. Okay, so what's the problem that we're trying to tackle? It's the fact that very, very few packages, new packages, are accepted on the first upload to CTAN. And almost none by new authors. So if you compound the two things, sending a new upload and it being your first upload, well, there are close to 100% chance that it will be rejected on the first try. So that's something that we'd like to tackle. This is what I will be discussing with you. So the solution could be read the documentation. It's all documented how you should prepare an upload. Okay, so RTFM. So there's a page on the CTAN website. How can I upload a package? This one is fairly short. And then there's an addendum. This one covers pretty much all the error cases that we've seen over the years, and I guess it has been the problems have been stacked. So in the end, the whole documentation is about 5,000 words. That's about 20 pages. Okay, so it's very long, and I guess that not that many people read the whole documentation. And I wouldn't blame them. So what should we do? When I was preparing my talk, I knew what I had to talk about because, I had already written the abstract. But I didn't know exactly how to approach the problem or the talk. So I was sort of goofing around, pushing it ahead. And eventually, I ended up on a Stack Exchange thread linked by Max, actually. Thread in which there was a link to this paper, which is actually just a one-pager by none other than Leslie Lamport. So it was very, very fitting to present it here. I don't know how many people here knew about this thing. So the paper, basically, everything is in the title. It says, state the problem before describing the solution. And Leslie was basically saying, he says papers in computer science, you can extend it to any other discipline, would be the same. He says, quite often in scientific papers, we have a statement of the problem, one solution that is proposed, and then a proof that the solution is indeed a solution to the problem using metrics that we choose such that, of course, your solution will appear as being the best one. Rings a bell to anyone? So basically, Leslie was saying, do this instead. We should instead state the problem, then state the correctness conditions. So what would be considered as a correct solution, then propose a solution and prove that you are indeed meeting the requirements. So this is what I will be trying to do. But, well, keep in mind that obviously I was using this approach, but I'm trying to pretend that I'm using this one, okay? But let's do it just for the sake of the presentation. So, what would be the correctness conditions to have a package uploaded successfully on CTAN? Or basically, in other words, what are we looking for in a package? Okay? And then we'll see what are our requirements to meet these conditions. So what do we want for a package to be accepted on CTAN? And bear with me for some of the icons. It's not always easy to find an icon to represent an idea. So first, we would like the package to be discoverable on CTAN or in the distributions. Just last week, Gerd, our webmaster, informed us that we reached the threshold of 7,000 packages on CTAN. Okay? So good luck being found inside this whole forest if, well, the aim of your package is not clear. Okay? So the package should be discoverable. We want to have clear copyright and licensing conditions, usually because it is free software. This one is sort of optional, but you know, usually if you write a LaTeX package, you want to be included in distributions, and especially in TechLive. And uploading to CTAN is the path to get inside TechLive, and to be in TechLive, you have to be free software. Am I correct, Carl? Good. So probably that you want to have to be free software. We want to avoid name clashes with other packages. I'll come back to that in greater detail. We want the package to be portable because, well, the distributions are offered on many different platforms. And, well, there are humans involved in this whole thing. So packages are not processed automatically. They're processed by humans, of course using some tools, but in the end they're processed by humans. And we would like it to be, we would like the package to be as easy to process by the humans involved. So as easy as possible. Okay? So now that we have these correctness conditions, let's see what are the requirements. We have 6 conditions. I have 7 requirements to show you. And it's just that some cover 2 conditions and whatever. Okay? So solution redux. So let's try to build another solution that is not read the documentation. First point, the package name. It's the most common source of rejection. It's just the name of the package. Okay? So we ask you to choose a descriptive and non-cryptic. Well, obviously, what is cryptic and what is not is open to debate. But so try to have a non-cryptic name for your package. Of course, this is pretty broad, okay? What is considered as descriptive and non-cryptic? Something you can judge as being very, very descriptive, but only people in your field will understand what it is about. I'll give a few examples in a moment. So, for example, very, very short package names. Well, sometimes when we design the thing on our own computer, we want a very short name because it's faster to type, and so on and so forth. Well, very, very short names tend to always be rejected nowadays, especially if there are no vowels in the name. Okay? Don't put a text suffix to your package. Maybe you developed it as thinking, oh, I'm doing this type of thing for tech, so I'll add a text suffix. They tend to be reserved for new engines. So unless you're an engine, don't put tech inside the name of your package. Okay? Aim at the universal. Here what I mean is that try to find a name that everybody will understand. So don't be too say, country or culture specific. Okay, so something could mean one thing in your culture and mean something completely different in another culture, and it just brings confusion. Follow the path when there is one. I mean that for some packages, there's already a sort of a tradition that has been laid out. For example, Beamer themes, they're all called Beamer theme something. So just follow the path, okay? TIGZ packages usually have TIGZ in the name. Thesis templates usually have thesis in the name, so on and so forth, okay? And you cannot say, well, yeah, but there's this package already in TechLive that it's not admissible, okay? It's just that some people have been here much longer than you and me, okay? I mean, there are directories in CTAN by the first name of a person, okay? So you have to have been there for a very, very long time to have a directory at your first name in the catalog. Okay, so let's see a few examples. There are fairly recent examples. We received this package QDraw, which was, well, not a bad name, but what does the Q stand for? Okay, is it quick? There used to be, I think, a drawing program called QDraw. We really asked the author, what does the Q stand for? I don't even remember the answer. But we proposed some other solutions, and he came up with something much more poetic than we proposed, OGDraw. This is pretty cool, I think. It's a very nice one. Org style. To me, as I'm an Emacs user, org would stand for org mode. Well, no, the author had no idea what was org mode. Okay, so it was there for organization. Okay, so we renamed the package as brand styler in the end, which was basically a package to take the identity of your organization and make templates for it. So the R at the end is interesting in this case. AP reacts. Well, for someone in the field of atomic physics, AP is a very common acronym. But if you're not an atomic physicist, well, what does AP stand for? Right?
Advanced placement.
Could be anything, okay? So it became atomic reactions, which I think you will all agree that it's a little bit clearer. Pong tech. So this is one where there's a tech in the name, okay? And Pong. If you're old enough, you think of the old game, okay? The first computer game. So it was renamed Mahjong Tiles. I think it was Carl's suggestion. I'm
not sure about that one.
Yeah. Yep.
They all blend together.
Carom is an interesting one. Carom is a type of billiards game, common in France. So it was actually a very good name. The problem with this one is that, and Carl discovered a couple of days later, is the fact that there's already a carom.sty file somewhere in TechLive. Okay, so name clash for this one. So we asked the author to rename the package, and actually it's actually clearer this way, Carom Billiards. Well, yeah, it's just a better name overall. And then there's this one that occurred recently, XO. It's actually a package to draw tic-tac-toe boards, okay? And that's something I didn't know, but tic-tac-toe is actually the name of the game in the US and Canada, but in other places of the world, it's called XNO or noughts and crosses in the UK and stuff like that, okay? I put ellipses here because we still haven't reached a conclusion. The author did not get back to us so far with a chosen name.
Dutch name for that.
Here I should just mention a funny story. Really, as I was laying out the plan of my presentation, I had just prepared basically this slide. We received an upload. The package was named CW. So 2 letters, no vowels. So if I just go back a second, it was certainly not descriptive, certainly cryptic, way too short, okay for the text suffix and everything. Well, it's just that for this one, the upload was by Jim Efferon. No. So I was slightly hesitant to tell him, well, you know, and it was actually a package to do Morse code. There's already a Morse package on CTAN, very, very old package, and he just wrote another simpler version, and CW would stand for continuous wave, which would be another name for Morse code. He ended up renaming it as Morse Simple because his package is actually simpler than Morse. I thought of proposing Walrus because Morse is actually the name of a walrus in French. So if you go from English to French and back to English, you get walrus. That fails the aim at the universal. You know? Okay, so that's for the name. Another thing that we ask, so that, well, if you want people to get interested in your package, first have a good name is a good thing, and then easy access to the documentation. I don't know if you're like me, first thing you look at, let's have a look at the documentation, okay? So build good documentation for your package also, but whether it is good or not, we ask you to provide some documentation in PDF format so that we can link to it from the CTAN site. Okay, so if the package has documentation, we put a link to it. We do not compile anything. So that's why you have to provide the documentation already compiled in PDF format. We won't do it ourselves. Okay? So that's simple enough. Just provide the documentation. That's it. The only pre-compiled thing that we ask you to provide is the documentation. Then, a README file. Well, it probably used to be more overlooked in the pre-GitHub age where README files were not as common as they are nowadays. So today they tend to be there. So README in any sort of format you want, so in Markdown or just pure text, doesn't matter. So what we ask of to be present in the README file, again, this is information that will be put on the portal. Short description of the package, who are you, how to contact you, and what is the license of the package. That's basically what we ask for in the README file. Some authors tend to give a lot of documentation in a README file. Doesn't have to be there. But this is the information that we ask you to provide. Be careful, the README file, the short description, should not, ideally, in my opinion, be a replacement for proper documentation. So I tend not to like, personally, a package that has a long README file and no proper documentation. Okay? I think the idea of the documentation is documentation in PDF shows greater care, in my opinion. Okay, so far so good. With these three components, so a good name, a README file, and proper documentation, we've covered a good chunk of the discoverability aspect of your package and also the clear copyright and licensing conditions. Next, if you want your package to be free software, you have to provide the sources of your package. And this is another place where some errors occur. So what we ask for in the sources is no generated files. So everything that could be generated from the sources themselves should not be included in the package. With one exception, the documentation. So we do ask the documentation, but nothing else. Okay? So for example, if you're building your package using literate programming, and the STY file is extracted from a DTX, well, just provide us the DTX. We don't want the STY. Okay? So no generated files. Ensure coherent licensing. This is something that we see quite often. One file says LPPL 1.3, another file says LPPL 1.3C. Petra doesn't like this. Okay, so try to have the same licensing conditions everywhere. Here I'm not talking about you could have two different licenses for different files in a package. For example, the package file itself is LPPL and the documentation is Creative Commons. That's fine. Okay, you may have two licenses, but if you're using one license, well, try to use the same license everywhere. No Git repository, please. There's a double entendre there. First thing is, not everything that is part of your Git repository has to be in the package. For example, you have a makefile to build the package. What good is it for end users to have your makefile? It's probably part of your Git repository. There's no real point including it in a package. So it's not because a file is part of your repository that it has to be in the package. So that's one thing. The other thing, and it goes with the fourth item, we don't need the Git repository inside the zip file. Because you'd be surprised, but it happens quite often because the Git repository is a hidden directory in the directory of the package, and people will just zip the whole thing and send us the whole Git repository in the zip file. Okay? So be aware of hidden files. And I would expect, I assume that a lot of mistakes happen because people will just zip the directory that contains the project and zip the whole thing, okay, using something like this. So zip the contents of directory pkj and pick up everything that's in there. Very bad idea. That's how you end up with the whole Git repository inside the zip file, because it will catch hidden files. For Mac users, there's an equivalent of this, is to use the Finder to zip, because the Finder, the file manager on Mac OS, there's an option in the menus to zip a directory. It does more or less this, and it catches everything. Okay? So don't do that. Instead, I highly recommend to explicitly mention each and every file that you want to include in your upload, in your archive. If there's one directory that contains great many files, well, just make sure that there's only the files that you want to include in that directory and nothing else. And please script this so that you don't have to redo it each and every time by hand. Okay? There are various ways to do it. There's L3 build nowadays. You can use plain old make files, various ways. Just write the command somewhere, but don't redo it by hand each and every time. That's where mistakes occur. Okay? That's another important aspect, is that LaTeX has absolutely no concept of namespace. So in a whole distribution like TechLive, ideally you cannot have two runtime files that share the same name. Otherwise, there will be name clashes. Okay? So you should, at all costs, having runtime files that have the same name as another one. So the very simple solution, you just include the name of the package in the runtime files. Eventually, well, just put it in all your files, of course, except README, okay? Don't name the README file after the name of your package, okay? Whenever sensible, just put the name of your package everywhere. This is a safe solution. Here are a few examples. Well, obviously, if we assume that your package is named, I'm done.
Done.
Fine.
2 minutes.
I brought my phone to have a timer, but I forgot to start it. So. Okay, so this one is pretty obviously correct. The second one, say you have a Python script that is used by your package. Well, just put the name of the package in the Python script. Okay. Documentation, obviously, if each and every package sends a document called doc.pdf for the documentation, you can imagine it'll be difficult to reach your own documentation. This is another one which would not be considered as a runtime file. It could be okay, but it's always safe to put the name of your package inside in the file. Okay, portability. Well, to be portable, you should follow universal standards, obligatory XKCD. If you haven't seen that one before. Okay, so what do we mean by standards? Basically, standards is basically Unix standards, okay? So what we ask is that you write at least the README file in English. As a Francophone, I don't really like to say that this is standard, but okay. Please use UTF-8 character encoding. Just line fin line terminators. This is another pretty common mistake that we see. If you're on Windows, basically, the line terminators can be proper to your operating system, so just use the standard for everybody else. And please don't rely on capitalization of the names to distinguish your package in any way, shape, or form. Okay, you cannot expect that on another operating system, the lowercase, uppercase letters will make any difference, especially not on Windows. Okay, so I have to go a little bit faster. Human processing help you by conforming to our preferred package structure. This is really coming from us, what will ease our processing of your material. So we ask for a very flat structure. It's not the time to show us your mastery of the tech directory structure. Okay? Maybe you've read it all, you know how it works. It's of no interest really for us. Just put it in a flat structure as much as possible. It will be simpler for us. We just ask that there is a top-level directory with the package ID as at the very top of your zip file. Don't include a tds.zip file in your upload unless requested by a CTAN or a Tech Lab administrator. Okay? So saying, someone told me that I should include it is not enough. If that someone is not either Carl or a CTAN administrator. Okay, so a short proof very, very quickly because I know I'm out of time. I'll host TUG in 2027. So this is an example for a package done in literate programming. You see very, very flat structure, very simple. And if it's not done in literate programming, so the style file or the package file will already be extracted, you can do it this way. Okay? Very simple. And well, it's a proof, okay? So you can see that this satisfies all the requirements that I mentioned. Okay. Package updates, if you need to do a package update, just go on the page of your package on CTAN, press the upload button, and you will be presented a form where you just have to fill in the new information. So instead of restarting from scratch each and every time, it's much simpler to do it this way. And you'll avoid a lot of mistakes. Okay. This is a place where I just like to take a minute. So other considerations. Your automation is our manual work, okay? And I see, I mentioned that especially for very, very frequent uploads that are done automatically. Like, well, it's a GitHub action. Each and every time that I make a commit, it could generate an upload to CTAN. It's probably very, very simple for you. It makes for a lot of work for us. Okay, so please take that into consideration. Master the tools you use. We tend to see that lately, script kiddies that are using the shiny new tools. And when we ask or for something or say, well, this is not correct, the answer can be, I don't know how to do it. I'm using GitHub Actions and I don't know how to customize it. Well, don't use the tool if you don't know how to customize it. Okay? Your users do not all live on your bleeding edge. Here, I'm talking about very, very frequent updates. Okay? I'm the type of person who updates TechLive once per year when they release a new version. So do you really need 3 updates per week? I don't think it's that much useful in the TechLive world. Okay? So please consider maybe just package a few bugs before making an update, unless, of course, if it's very critical. I mean, we don't mind these type of things. And when you present a new upload, if you have suggestions for the topics that are attached to a package, they're always welcome. I'll skip AI considerations. It's a whole other topic, and I'm out of time. Yep. Just one more thing.
Quickly, please.
Yeah. We always reply. Okay, so if you send something, an upload, we always reply. So if you don't get a reply for some reason, reach out to us. It's not normal. It's probably that there was a problem somewhere. For example, we're trying to reach you, it doesn't work because you haven't provided the correct email address. Okay, so we always reply. And if in doubt, you can always write to us. Okay? If you have any question, we're there to answer your questions. Sorry about the extra time that I've taken.
We do have someone following you. So sorry.
Boris?
Yeah, I have a short question from chat.
Yeah,
Very, very short remark
Yeah,
from
that's fine.
me.
Yeah, no, we're good. You can have a question. Yeah.
Okay, one question. Only one question. He'll be available to chat. Yeah. Yeah. Go ahead.
Just a question, no answer.
Okay, the question is, the user asks whether... The user asks if they have a low if they have a package with a low-level library, bundle it or have it 2 separate packages. For example, if they have TUG package and low-level PGF library with it.
It depends.
And the answer is it depends.
Yeah.
Okay.
In that particular case, it would probably be better as one package.
Okay, one package. So one visitor, maybe I just say it's very short remark and I really want to tell it. It's very short. I just want to say that 10 years ago at Bahotech, I presented a talk where I compared my experience submitting packages to CTAN, CRAN, and CPAN. Was pretty, and my conclusion was that the best, the most helpful, the most warm, the most human maintainers were at CTAN. And now it's 10 years later, it did not change. I have experience with others, and just wanted to say that we are all so grateful to you, and I am especially grateful when you find my temporary files, which I usually pollute my uploads. And thank you, and sorry for being sometimes difficult.
I just want to say, nowadays, there would be no tech without people.
Oh,
Tech would not exist as we know it without people.
Yeah, and there's probably a moral that if you want to host CTAN and you're the one and only person supporting it, for those of you who've been here a while. Okay, enough of that. So are we set? Okay, so we're ready to go on to the next talk, which certainly has the most interesting title of the whole conference. So you'll have to wait a moment. I'm not going to give the remainder of the title just to keep the mystery going. So this is a remote presentation, Paulo Ney de Souza, and his talk is entitled A Family of Strippers.
Thanks everybody for being here. I'd like to talk today about a program that's been quite a while in the making. I first met this problem at the mid-80s when I tried to write unsuccessfully something to separate mathematics from text and basically to extract text from a LaTeX file and figure out for the first time how hard it would be. Soon after that, a program appeared called DTAC, based on LaTeX, and for quite a while it was an extremely useful program. But LaTeX evolved rather rapidly from a simple $sign and to separate mathematics from text. We evolved into a number of environments, and the problem became more difficult, and today DTAC is not able to act on the simplest files that you can feed it. I try then to sort of use the same approach, which was to list the same approach used by DTAC, which was to list all the environments and how to treat each one of them. You know, if you want to extract the mathematics inside it, if you want to extract the text inside the mathematics that is inside an environment, and deal with each one of the cases, probably using some more modern tools for doing the parsing. There's a lot of modern tools today to do parsing of programs, stuff which is way better than what we had back then, which was LaTeX and the tools that accompanied. But even then, you know, we don't have a full TAG parser independently of TAG itself. And this talk is about, you know, the challenges of using a pseudo parser, you know, something that parses part of the text of a LaTeX file, and using it in order to extract mathematics and extract text so that it can be analyzed separately as one may need it. The uses for it are obvious. You know, my first use was spell and grammar checking, you know, but today machine translation of technical books and full text search, you know, training of large language models, accessibility it comes as one of the requirements that one really needs to know the boundary of mathematics and text within a PDF file, within a source file for that matter. LaTeX is a programming language, not a markup language. So if you look from from that view, any tool that reads a TAG file without running TAG is basically writing its own interpreter. And that interpreter is bound to be incomplete unless you put a lot of time into it. What makes it so hard? It's, the language is, first of all, we have a problem which a language which is Turing complete, contains a Turing complete macro system, and user-defined commands everywhere these days. The files are extremely more complex today than they used to be, and optional arguments, stereo variants, cat codes, meet document, verbatim environments, math notation versus math prose, and on top of it all, we have the multiple language per document problem. In science, for example, it's extremely common, not just in citations during the text, but on bibliographies that extend over several different languages, including right-to-left scripts, CJK, language that have ligatures which are specific to the language, and even fonts that have discretionary ligatures which are specific to the particular font. So that complexifies the problem even further. So my idea was to, I told you that there are some very developed tools for doing parsing these days, but I shy away from dealing with them and try to use ready projects which have been tested and established in terms of parsing TAG. And I choose the four that I consider to be the top ones, which is LaTeX ML, LaTeX Tom, TechSoup, and Pandoc, and then use them as a module inside a program, almost in a way that you could replace one with the other, using them just to parse and to provide the tree with the separation between text and mathematics, and also to experiment to see which ones would provide the best results. LaTeX ML was the first one. It's an ambitious approach. We re-implement Stack Expansion Engine in Perl, and it produces XML, MathML, HTML, handles almost everything that you would have on a normal file, on a standard file in LaTeX. It deals with a large percentage of the files which are contained in the archive, for example. And it's also in active development, supported by NIST and AMS and a few others. For text extraction is very accurate for well-behaved documents, and allows the mathematics to become MathML. The limits are that it's slow. It has a very complex. It's not part of TAG Live. It fails on certain macros, and it has no multilingual text separation. On text separation, you do want each language to be separated in an independent file, and if possible, for those files to be tagged with BCP47 so that you can easily feed into other tools like Language Tool or spellers for the particular languages and proceed with analysis. None of that is possible with LaTeX ML. LaTeX Tom is as a parser which is directed to certain specific and limited commands. So if you want to, for example, obtain metadata out of a file, the author, the title, the pagination, the address of the authors, and so forth. It's an exceedingly good program, but in order to parse a general LaTeX file, all the way down to the end and do extraction at every change in between mathematics and text. It lacks and is an incomplete parser by design. It's not built to parse the whole document. It's built to parse only certain specific parts of the document that you may need ahead of time. It's fragile on complex macros, absolutely no language awareness, and is minimally maintained these days. So you even end up with commands which are unrecognized inside text nodes, which is undesirable. Then the next one that I tackled was TechSoup. It's one of the first times that Python met LaTeX very successfully, and this is built on sort of the same ideas of beautiful soup, and I guess even the same framework, and it parses tech into a navigable tree, which is really, really nice, and allows you to sort of pick up each one of the elements and analyze it for mathematics and for text and separate them. It handles balanced braces, optional arguments, and it's good for scraping content, and that's mostly used for scraping contents. The limits of TechSoup are that there is no macro expansion, breaks on very simple stuff like verbatim and listings, absolutely no language separation, and fails on very simple unbalanced braces, and most of the use of it is as I said, for text extraction, for scraping content out of LaTeX files. And then the next one that I approached was Pandoc. And Pandoc has a different approach in, it is most of you know already what Pandoc is, but Pandoc is a Swiss knife tool that allows you to change formats among a humongous amount of formats, and it reads the LaTeX tree, and you're able to even extract plain text out of it right away. But most beautifully, you can insert some markers on it with a pre-filter, and then establish what you want it to do with certain environments that it doesn't know about, and then and later with the processor itself, extract what you want out in text and what you want out in mathematics, and deal with them appropriately. If you compare them, you can get an idea right away. LaTeX ML is the second most capable one, and Pandoc is very able to deal with it, because it doesn't require any. None of those require any tech run. They run by themselves within their own environment, and Pandoc is extremely fast and is able to do the separation very well. None of them handles multilingual ligatures, for example, and the way that we chose to build this is almost in a way that you can use this as a plug-in to the main program. So you can basically choose to use LaTeX ML, LaTeX Tom, TechSoup, or Pandoc, and run to get your extraction. So how does this work? It works very much in the same way that the old DTAC worked. Some rejects, some heuristics, and marking up, inserting markups in the text when you want things to be be sorted out in a different way, and then picking them up later. Listing the environments that you need specific treatment. Some environments are scraped altogether. Some environments are searched for text within math mode, and some environments are, discard the environment and use the full content of the environment in a way that you can update this list as you go, so that if you write your own environments, for example, you can add this to a list that will be searched and that will be used for the extraction. The pro stripper, the first one is literally, the core idea is to use regex, parse it up and try to tell them which environments you want and which environments you don't. The Python strip is a step forward from that, but it almost works exactly in the same way. A dictionary must be maintained with the list of the environments, and how you want it, it to be dealt with. But it contains no font ligature awareness. Mathy Handley is very crude. Polyglossia presents its own problems, and it is still a very hard problem to solve, though much better than anything that you can get out of DTAC. The fundamental limit of this whole thing is that they parse, all four of them parse the source of a LaTeX document, but what we want is the text of a compiled document, and these are not the same thing. LaTeX is a programming language, and you can literally create a file that at every turn of a processing of it by LaTeX, it will produce a different output. It will change itself in order to produce a different output. So custom macros, input chains, cat code changes, floating code ligatures, language switches from packages, all of this makes sense after tech has run, but not in the source that you may have at your hands. So with a Pandoc stripper, we try to start with the LaTeX, go through a pre-filter that do the macro expansion, and marks the languages before you do any further processing, and then with a simplified tech, we take the markers and analyze them and separate them and deal with them in order to obtain separation of languages, etc. It's the only one that does separation of languages in a sort of a nicer way among the four in the set. The pre-filter, of Pandoc scans the preamble for a new command and does the macro expansion. I think it uses only 4 levels. Yes, only 4 levels. It detects language declarations and uses BCP47 tag map in order to mark them up, and injects certain tokens at language switches so that it can be later dealt with when you get a sort of a JSON file, or you get a tree that you can traverse and separate them, and strips the noise out, like things like label, to-dos, and include graphics and so forth, and then sends it out to be processed. And we have a math filter that also allows you to deal with the mathematics, or to just put a marker that area contains some mathematics in your file, and also to deal with the issues of text within the mathematics, which also is extracted so that you can deal with it. the good of it is that citation handling is performed at a very high level. It's able to understand certain language of certain of citations which are prepared appropriately, and then you can send them and separate those later for text extraction. If knowing these limitations and knowing that we wouldn't be able to go much further with a lot of this, using those 4 preprocessors, I tried another idea, which was to create a stripper that would be parsed by LaTeX itself, by TeX itself, basically to be processed by LaTeX, and allow LaTeX to do with the text separation and the tagging and the ligature handling and so forth. And I kind of stole the idea from a package called Spellings, which is it's in the repository, and it's part of CTAN. Not very usable these days because of lack of maintenance, but that it does use this idea in order to do spelling of a source LaTeX file. And so the idea was, it looked good in the beginning. It would have 0 overhead if it could be built. Custom macro expansion wouldn't be partial like the other cases; it would be full. Language separation will be exact, and font ligature could be dealt with, and footnotes could be dealt with. Noisy command stripping, and side command handling. Speed would be 0 overhead, since one would probably be running LaTeX already, and the only problem is that you need processing. So I settled on using a Quantic stripper when no full build environment were available, quick extraction without compiling, and standard LaTeX and common packages were used, and then using LaTeX stripper, which was a little bit more evolved, using when I need exact language attributions, when I need custom font with ligatures, and I had a file which already compiled under LaTeX. LaTeX obviously, provides a whole environment, embeds Lua 5.3 interpreter inside, and any text build a node list for each paragraph. The tree that describes the text and the mathematics is readily available in there, so one can easily traverse it and obtain the information about text and mathematics. So we started out with a text source, go through a LaTeX macro expansion, get a node list, and again with a Lua walker, we go into this node list to obtain the particular extraction, and then do the output on a per language field in text and in JSON. It has a Babel track, a Polyglossia track, so it has no information about BCP47 languages inside. It uses the information which is inserted there by Babel and by Polyglossia, and which makes it, one of the first fully Polyglossia ready, fully BCP47 ready programs in our multi-language environment. Lots of problems in dealing with it. There are LaTeX has 2 renderers. One is the default render in Lua, the other one is half bars. They deal differently with with ligatures, and so we have to expect both, and then proceed to analyze how to do ligature handling for each one of those. And then, you know, we had to deal with a few other things like language boundary space and footnote extraction, you know, and mathematics is once it's recognized, it's marked up in the text as mathematics or display mathematics, and bibliotech integration is fully ready. You know, you don't need to do anything besides marking up your text for languages, and you're ready to do this. You know, you can just use package stripper in a file, run Lua LaTeX, and then you get, you know, from mybook.tech, you can get mybook en-us annotated.txt, mybook extract.json, mybook fr.txt, mybook ja.txt for Japanese, and so forth, and have every single piece of text separated by language on the other side, with a parsing which is completely done by tech. The two groups side by side, the stripper, the Lua LaTeX stripper is a clear winner, you know, by dealing with custom macros, math handling, you know, multilingual output, Babel support, Polyglot support, you know, BCP47 native, and dealing with ligatures and footnotes and bibliotech citations with zero overhead is a clear winner. You can get access to it by going to my GitHub page, Paulo Ney, Pauloney, and downloading all 4 pseudo-handler strippers plus the stripper package under Lua LaTeX, and I hope you enjoy. Try it out and send us some lists of problems or wishes that you may have. Thanks very much for listening.
Yes, I do have the time.
Oh, good.
I just want to say I'm sorry for the malfunctioning of the slide during the recording. You can get, you know, the full set of slides at the website for the conference.
Hi, Paulo. Norbert Breining here. Thanks for your presentation. I'm always happy to see new text extraction features, because we are fighting a lot in archive, because we get a lot of, we have to text extract and do text overlap and this kind of stuff. Have you compared to PDF-6, which is one of the standard extraction algorithms? This is the one question. And the other is, how does it deal with these nasty little PDFs that contain like spirals and whatever other things? So that you can always work on LaTeX only. Does your code do anything on PDFs by itself, or only start from LaTeX?
Well, we may not have time for all the questions there. There's like 5 or 6 questions there. Yes, we did compare that with PDF-X, and the coverage on the 4 strippers, you know, the beautiful soup, you know, text soup, and then LaTeX ML and so forth. The coverage does vary, and but it's superior to do anything on the PDF. It's superior, and but nothing compared to the stripper written for Lua LaTeX, because that is 100% accurate. You know, it's basically, you say, I want math, I want text, and you get math, you get text, and if you have your bibliography in, like, you know, 20 languages in your bibliography, you get all of that separated in 20 different files, marked up by BCP47, and everything's ready.
I will try to address some of your other questions. What was the other question?
Now for me, so we do normally text extraction from PDF, even if we start from a LaTeX document. That is not optimal because, well, we know there are a lot of problems there. How good does it compare to PDF extraction from PDF when you run it over the LaTeX source? Considering that it might have a lot of complicated macros and whatever, we get files that have every single word replaced with a macro, and so I'm not sure how good it deals with that.
Yeah, well, there's a divider here. You know, there are 4 strippers which are written for pseudo parsers, and yes, indeed, you know, complicated macros botch things, and so LaTeX-ML is changing right now, and so we'll change accordingly, and hopefully, you know, we'll still cover most of the files. But yes, if you have complicated macros and if you have complicated stuff, it will botch those. The LaTeX stripper is 100%. Sure, you know, there's absolutely, you can do spirals, you can make your text snakes on Tixie, and it will take those and serve them back to you as is.
Great, thanks.
Thank you.
Hi, Marcel Krüger here. I'm wondering, you mentioned that you have this handling for ligatures with the Lua renderer and the half-pass renderer. And it seems like that is a bit unnecessary if you just hook in a bit earlier and just extract the text before the font shaping is happening. Did you consider doing that?
Well, I have to take whatever LaTeX can offer me, and I have to tell you that you know, I'm not you know, I'm a mathematician and not a very well-versed tech programmer. And so I may be missing something that would be easier to deal with. As you parse your, you know, the word differentiable over, you know, over LaTeX, you get, you know, depending on the font that you have, you may get a ligature. Depending on the font that you have, you may not get a ligature. And so recovery from ligatures is a big part of the LaTeX stripper right now. But I would be ready to listen to other ideas to deal with that don't have to read directly from the LaTeX source. I mean, reading from the LaTeX source is sort of a no-go because of the fact that LaTeX is not a markup language. LaTeX is a programming language. You know, we're interested in the text that shows up in the PDF. You know, I can write a LaTeX file that requires an infinite amount of processing in order to get the results that I need, the results that I expect. And so analyzing, you know, after the parsing by LaTeX was the objective of the Lua stripper. But I'll write you, and I want to listen a little bit more careful to what your ideas are for not having to deal with ligatures, because that will simplify the parser tremendously.
Thank you.
Okay, perhaps we could thank the speaker again. Very nice talk.
Thank you very much.
Hi. Okay, can you help me get correctly combobulated?
Yeah.
Like this?
Yeah.
No, just a minute. Oh, yeah, you got that. Yeah, sorry.
Very well. And then, oh, huzzah.
Are you okay?
And then just wait, we'll get to your slides. Yeah.
No problem. while this transition happens, I simply have a tongue-in-cheek question for the conference organizers. If scheduling a talk called "A Family of Strippers" right before the Catholic theologians was a form of hazing.
Pure coincidence.
Yeah, all right, understood. Very well.
So do you want to?
I'll introduce myself. So
introduce
just let me know when you're ready for me.
Introduce yourself by all means.
I think that'll just distract. Is this okay for folks in the back?
I think the mic will help.
You think so?
Yes.
Okay, take a chance. Thank you,
Is
Corey.
this okay? All right, very well. All right, good afternoon, everyone. This is my first time at any Tech Users Group conference. Thus far, it has been a lovely experience, and everyone has been deeply welcoming. I applaud in a special way Max Chernoff as the local organizer. This venue has been wonderful. Being right along the riverfront has afforded me the opportunity to engage in long outdoor exercise in the fresh air that feels much better than the air back in Houston, first thing in the mornings. And Carl Berry was most communicative and helpful in making sure that I was able to make it here to speak. My kind of recurring internal theme through this conference has been rethinking and reconsideration. Yesterday afternoon, my dear desk mate for the duration of this conference, Professor John Lienhardt of MIT, made me think seriously about long-form assignment submission and styling requirements for my undergraduate and graduate students. Yesterday morning, Pavneet Arora inspired me to reconsider aspects of Zettelkasten and my academic notes to manuscript writing and research workflow. And of course, Friday midday, Timothy Erickson and Arush Bhatt, I'm sure inspired basically all of us who work in education in some capacity to reflect deeply on what accessibility in the materials that we present really is, and I give to them the highest of praise and encourage anybody who might be tuning in online to revisit that talk from Friday. There have, of course, been other talks during which I have scribbled ideas about LaTeX to revisit or reconsider in the near future in my digital notepad. In a way, my own talk is about revisiting or reconsideration. I work in a general academic area, as I'll discuss in a moment, in which the vast majority of my colleagues are simply unexposed to LaTeX. We do not work in a LaTeX realm. We work in a word processor realm. I've prepared this talk accordingly with two audiences in mind. The first is everyone here at the Worldwide Tech Users Group 2026 conference in Calgary, maestros and maestras of tech and LaTeX. The second is colleagues who are might be positioned to tune into this online, maybe at a later date, check in on YouTube or some such thing, but are totally unfamiliar with LaTeX. So with that setup, I hope that will explain for all of you why many of my slides seem to be communicating at two levels. That's because I am indeed intentionally communicating at two levels. Is it arrow down?
Yeah.
Thank you.
Backwards arrow.
All right. I serve as lecturer in religious studies at the University of Houston, course developer and instructor in the THD program, Theologiae Doctor, Doctor of Theology, at St. Leo University, and instructor of Catholic theology in the core curriculum at the University of St. Thomas in Texas. Broadly, I study patristics, that is the writings of the early church fathers, and the theology of the Latin Middle Ages and Greek Byzantium. My research topics include Greek patristic Christology, understanding of who Jesus is, basically, and cosmology, understanding of the structure of all that exists, things visible and things invisible, plus their reception among Latin scholastics in the Middle Ages. So I'm the author of a brand new historical monograph published by the Pontifical Institute of Medieval Studies here in Canada, but way over in Ontario, called Maximus the Confessor's Thomistic Legacy. So what on earth am I doing at TUG 2026? I have a kind of parallel set of interests that are somewhat hobby and somewhat professional, a kind of perfect blend of the two, in which I advocate software freedom in academia, throughout academia, teaching, researching, and so on, by delivering talks like this one. So this fits within that kind of second portfolio, as it were. For more about anything about me, go to corystephan.com, which also links to my Gopher hole. That's for the LaTeX tier of my talk, that mirrors most of the material therein. To start thinking about LaTeX for humanities, or divinities in my case, disciplines, in general, we have to think about LaTeX beyond its normal bounds. The world's best established software system for typesetting and document formatting, LaTeX has been popular throughout mathematical and physical sciences for decades, as plainly evidenced by the fact that many of you folks have decades on me in terms of years on this earth, and have known each other and worked with each other for longer than I've been alive. The utility of LaTeX for humanities disciplines, however, tends to be overlooked, as evidenced by the fact that I doubt that any but one colleague that I know, most broadly understood, actually uses LaTeX in any professional capacity. At the same time, I contend that LaTeX can be used for typesetting in most instances in which a scholar of humanities needs to present her materials. And this is for that online tier, right? I prepared these slides in LaTeX, in fact, with less frustration than I would have had with a graphical presentation program as one file. And there on my GitHub repository, Historical Theology, LaTeX Talks, a person may view the source for these slides, and also a preprint, I believe it's called, for the subsequent tugboat entry. In today's tutorial, my aim is to introduce attendees at both tiers to the use of LaTeX for a common task in humanities scholarship, namely typesetting texts with unusual line length and other organizational needs, such as primary texts with accompanying translations. The thought experiment for the day, in which I ask all of you to join me, will be that of determining how to prepare a handout for a historical conference or class presentation with perfectly organized excerpts of a Byzantine Greek text and an original English translation placed in parallel. Of course, before we get into that, we need to think about why somebody in my areas of work, as most broadly understood, might choose LaTeX at all. In humanities, or in my case, divinities disciplines, such as my own area of historical theology, editors expect us to prepare our materials for publications with bug for bug, and I chose that very intentionally, compatibility with Microsoft Word for back and forth markup. In practice, this expectation requires the use of word processors. Don't rely on Pandoc and Magic Sauce when somebody's expecting bug for bug compatibility. So I use LibreOffice Writer, for example. Prepare according to an editor's and press's specifications, send to the editor, editor writes comments and marks, sends it back to me. I reply to those and insert in lines back and forth, and the same docx file grows into this vast cobweb that eventually becomes, God willing, a publication. A word processor, like LibreOffice Writer, presents material in a what you see is what you get style, or WYSIWYG, as we say. While one writes, one is simultaneously thinking about and working on formatting. And so it is for that second audience, the audience online. I say, how many times have we gone, oh phooey, this footnote got messed up in its alignment. Now I need to spend the next however many minutes not thinking about my work itself, but rather fussing about the editor's exact specifications for a format, and then poof, the train of thought is lost. The break between classes comes to an end, and one is just frustrated. Enter the typesetting language. In a typesetting language such as LaTeX or Quantic or Typest, either of which a humanities scholar might also choose for various reasons, though I'll talk a little bit more about that later. The stuff we're talking about today is really LaTeX exclusive. One is only concerned about the structure of what one is writing. One declares that specific characters or items will be in certain categories of writing things. Boy, explaining this in front of Mittelbach and Fischer is making me a bit self-conscious. One declares that specific, this is how LaTeX works. One declares that specific characters will be in certain categories of writing things, heading, paragraph, footnote, accent type, typeface, etc. And one allows the program to compile one's writing that is really a kind of code into a tidy formal document, nearly every time. Preparing a curriculum vitae, which is actually what prompted me to learn LaTeX. I grew tired of wrangling a curriculum vitae in a word processor and looked for something better. Or a conference handout, like I'm discussing today. Or another document with unusual formatting requirements becomes about the writing itself rather than about fussing about all the little odds and ends of the formatting. Of course, there's a real investment of time in the front end, but then you just get to sit down and write. To learn LaTeX as a scholar in the humanities, I actually think that it's worthwhile to make a couple of specific recommendations. Here are the two that I recommend. The first is what I actually used to learn LaTeX, the not so short introduction to LaTeX. This is available in this GitHub repository. The second is what my one colleague I know who also uses LaTeX learned to learn LaTeX, used to learn LaTeX, modern LaTeX, and that's available in this GitHub repository. Either guidebook may be used to begin to learn how to typeset prose, letters, ancient languages, and other materials that are relevant across the humanities without the strong front-loading of mathematics and physical sciences that one finds in other introductions to LaTeX. Either option, in other words, provides an efficient introduction to LaTeX for a scholar in a humanities discipline. One of the beauties of LaTeX is that it's so vast with so many different pathways down which one can explore, but one does not actually have to learn all those pathways. One can just learn a few specific packages or tools that one needs within the broader ecosystem and make use of those. All right, now let's pivot to the whole handout thing. There are many ways to set parallel text in LaTeX. The simplest, or at least the simplest of which I am aware, is to use the community package called Parallel, which is included in TechLive, McTech, and other LaTeX distributions. For full documentation, visit ctan.org/pkg/parallel. To start using Parallel in any LaTeX document, include the following in the preamble: use package Parallel. Now, why am I saying this at the TUG? Well, for a newcomer to LaTeX, it is extremely easy to prepare an entire document only to have the whole thing fail and really struggle to figure out that the problem was just forgetting that pesky line in the preamble. So I'm going to reiterate that a couple of times for the benefit of that second audience, the online one. For example, newcomers, here is an abbreviation of the preamble to this Beamer, that is LaTeX presentation file, with the most important entries including, well, Parallel, because I'm using Parallel in this talk. The document class is Beamer, that is a presentation with that very important aspect ratio 16:9, which was required by the TUG folks. Use theme Göttingen, and that's basically what this theme is, a built-in Beamer theme. I use a custom typeface because I'm showing polytonic Greek later on, but use theme Göttingen will get you 90% of the way there. Ellipses, somewhere in the middle of all that, I've included use package Parallel, and then finally a nifty title with a couple of line breaks and a hyperlink so that on every slide, everything just automatically shows up in what I consider to be a neat setup. To begin using the Parallel package, after declaring it in the preamble, the basic format is, well, quite basic. Begin parallel text, left space adjustment if needed, right space adjustment if needed. Then on a new line, parallel L text, left text row 1. New line, parallel R text, right text row 1. Parallel par triggers a line break, and then parallel L text, left text row 2, and so on, all the way down until the end of the parallel text. An extremely basic example then of something that I might set in parallel, the start of the traditional Latin prayer, the Ave Maria, began parallel with no spacing changes for the columns, parallel L text, Ave Maria, parallel right text, Hail Mary, parallel par to trigger a line break, parallel L text, Gratia Plena, parallel R text, full of grace, and then I've just inserted some ellipses here and parallel. And that's how all of that looks at the bottom. First two lines perfectly set left to right with equal spacing and all of that. No fussing with word processor tables here, folks. For advanced setting of parallel text in LaTeX, especially long form setting like a critical edition of an ancient text with accompanying translation, one really ought to learn the two interconnected and frequently updated community packages, reledpar for parallel typesetting specifically, and reledmac for typesetting academic editions in general. It includes all sorts of features like automatically configuring a critical apparatus, which is an extremely powerful thing to do and basically impossible in, say, a word processor, for example. Both of these reledpar and reledmac packages are bundled in TeXlive and other LaTeX distributions. Reledpar and reledmac are purpose-built for long-form academic parallel texts. Their functionality actually at this moment in time cannot be duplicated in any software of which I am aware. So I specifically looked into, can you do anything like this, say for example in types, and the answer is a categoric no. In fact, types basically can't do parallel text, period. I looked, can you do this? Again, I mentioned the word processor, the answer is no, and so on and so on. To achieve this, setting a critical edition for oneself, say to make a handout, which would be the context for doing that sort of thing, the example to have it turn out cleanly is basically to learn LaTeX and then learn reledpar and reledmac. These two packages, it's important to note, are meant to replace older methods of academic parallel text preparation in LaTeX that one might find in web searches. The most obvious example of this is if you cut out the re from both of them, the older ledpar and ledmac, no more. Use reledpar and reledmac, which are total rewrites with vast expansions of functionality, including full Unicode support, working with Lua LaTeX, and so on and so on. For full documentation, go to ctan.org, the package page for reledpar, and the package page for reledmac. And I'm going to hit this in again for newcomers, that second tier viewing online. Remember in the preamble, lest everything should fall apart. The most important packages for handling text outside of Latin alphabets are the community packages Babel and Polyglossia, which are included in TeXlive and other LaTeX distributions. Although it is possible to convert a project from one of these, let's say, meta packages to the other, oh, that typo will be fixed in the Tugboat article, one ought to invest the time to choose carefully between either of these two at the start of a long-form project. They have similar, what's the term I'm looking for? Styling or code words, let's say, but they're not identical. So it's not trivial, not terribly burdensome, somewhere in the middle. But if you're starting a long-form academic project that will take years, just take the time to figure out which one to use at the front end. How do we choose between Babel and Polyglossia? On the one hand, it might look very easy. In the LaTeX Companion 3rd edition, published very recently, 2023, Frank Mittelbach and Ulrika Fischer, both of whom are fellow speakers here at TUG 2026, suggest that despite the fact that Babel is older than Polyglossia, Babel is generally preferable. Quote, unless you are in a special situation where a language or script is notably better supported by Polyglossia, the recommendation is to use Babel with all engines. Of course, in my areas of work, that's a big unless. Since now Babel and Polyglossia technically support the exact same set of languages. But a situation in which, say, an ancient language is better supported than polyglossia in polyglossia than in Babel is much more common than in a modern language. That's where it becomes very important for one of my colleagues to go read the documentation for both and figure out, okay, which one do I need right now? This situation no doubt will change over time, but that is the state of affairs in 2026. Now, in old web forum discussions, one might read that Babel will work better with Lua LaTeX, whereas polyglossia will work better with Z LaTeX. This is why we don't go read old web forum posts. In 2026, that is wildly incorrect. One could choose either Babel or polyglossia for either of the two mainline LaTeX engines that are built with full Unicode support, Z LaTeX or Lua LaTeX. Of course, results might vary in compilation on either of these engines depending on the specifics of a given project. To make an informed choice, where we need to go right now in the kinds of work that I'm in is just straight to the official documentation, read it, and figure out which of these is going to work better for my project, and possibly even do a trial run with a short amount of text, frankly. Now, learning Babel, well, here I'll earn some brownie points. I recommend Chapter 13, Localizing Documents in the LaTeX Companion, 3rd edition by Metelka and Fischer. This chapter succinctly introduces localization in LaTeX via Babel in a practical, didactic teaching style. So that's pages 297 to 342 in the 2nd volume of the LaTeX Companion, 3rd edition. Believe it or not, the LaTeX Companion is the thickest full set of books that I own, even as a historical scholar with a wide variety of lexica. Take that for what it is. Okay. It's even thicker than my patristic Greek lexicon, which is some 1,500 pages. So, yes. All right. Now, to learn polyglossia, I recommend the package's official documentation, and that is on CTAN. PKG polyglossia. Okay, do as I say, not as I do. Here I will model polyglossia, which is just what I happen to be familiar with using for polytonic Greek, ancient and Byzantine Greek. I read the entry in the Metelka and Fischer book the day before that submitting these slides was due, so I did not have time to learn a whole new language package. But after reading that recommendation, I certainly intend to try Babel for a future project and see how it works. To use the package polyglossia, remember to include it in the preamble. Then after the beginning of the document, but before the actual type, declare the languages and their variants. For example, here is this .tex files polyglossia declaration. So the declarations I needed to make this Beamer presentation. Begin document, set default language to English, set other language to Greek with the variant ancient, and that variant ancient is very important. It's important to read the documentation to see what variant options there are. For example, a German speaker might need Austrian or Hochdeutsch or some other option to be selected. In the case of Greek, none of the polytonic marks, the breathing marks or the accent marks, would be able to appear without choosing that option, and hyphenation would be a disaster. But with this option selected, hyphenation and breathing, accent marks work, breathing marks work, and hyphenation mostly works. Now, when using one of the other declared languages, toggle it when needed. A language may be toggled for a long excerpt, like so, begin language, then the language's text, and so on until the end of the language. For example, begin Greek, and then here I'm using John chapter 1, verse 1 as an example from the Christian New Testament. And in the Tugboat article, I'm also going to use the start of Homer's The Odyssey as an example. So you see begin Greek, then a line with a line break, another line break, another line, and so on, and Greek. By the way, here and in other code samples, the Greek text is spaced incorrectly due to a limitation of the package LST listing, which I've learned in this conference is basically becoming obsolete, but no, it's not becoming obsolete. Okay. In any event, there's a limitation with the way that it shows spacing in non-Latin languages, and so that's where we get this result. If somebody wants to talk to me after the talk about a potential fix for that, I would be all ears. In any event, the result of all this is this very clean, lovely portrayal of John chapter 1, verse 1, and archai in hologos, kai hologos in prostontheon, kateos in hologos. Now a language may be toggled for a single line, like so with polyglossia, text, language, text in language. For example, text Greek, Greek text. This might be used to insert a keyword or a short phrase or even an inline quotation. For example, hologos, produced with text Greek hologos, inside running prose. Now, to combine parallel and polyglossia for just about the simplest setting of parallel text that I've been able to figure out to achieve in LaTeX, begin parallel and then determine if you need column width adjustments. Text language parallel LText, ancient text line 1. Parallel RText, modern text line 1. Parallel par to trigger a new line. Text language parallel text, ancient text 2. Parallel RText, modern text line 2, and so on, all the way until the end of the parallel. Of course, this becomes wildly tedious very quickly for anything more than certainly more than a few stanzas of poetry or some such thing. I might even say more than a few lines. And this is why I remind everyone of relid par and relid mac for anything more complicated and or significantly longer in making parallel text displays. Of course, here what I'm going to show is the simplest example, because the simplest example is probably the best way to get started, and also what most people will want in preparing a simple handout, right? The idea in a handout is show as little as is needed to illustrate a thing, and so here I'm showing, similarly, as little as is needed to illustrate the thing. Here's a simple example of parallel and polyglossia working in combination to display how I might show on a handout my own translation from the opening chapter of my new historical monograph, Maximus the Confessor's Thomistic Legacy. So you see begin parallel 0 spacing left, 0 spacing right, text Greek, parallel LText, then the first line of Greek, parallel RText, the first line of English, parallel par to trigger a line break, text Greek, the first line in the Greek, parallel RText, the second line of Greek, parallel RText, that second line of English, and so on, down to the end of the parallel. Inserting this into a conference or classroom handout, the result might look like the next slide. So here, I'm not going to read the Greek nor the translation to you folks. That's not the point. Rather, I want to point out a few really compelling things here. First, I'm using the cochineal typeface, which is specifically designed such that Latin and Greek look how Latin alphabet and Greek alphabet are supposed to look, but with equal spacing and this kind of consistent flow. And so that's, again, that's cochineal. And so there's this really neat flow in which the Greek, polytonic Greek, looks like polytonic Greek. It has a kind of homage to a Byzantine manuscript or some such thing. And the Latin text looks, right, it looks like Latin alphabet text, how we expect in modern English. And yet the typeface is consistent, right? And so that's not necessarily special to LaTeX, but it's compelling that there are options like this built into TeX-Live, is what I want to say, right? A person doesn't need to go hunt down new things, just install TeX-Live and boom, there it is. Maybe more seriously, thinking about something LaTeX specific, notice how all of the spacing just works. Earlier in the talk, I said no messing with word processor tables here. I'm in a discipline in which that is by far the most common way to set parallel text. In fact, it's what's expected by most presses for submissions of parallel text. And good heavens, is that ever a frustrating way to handle parallel text. Everything breaks all the time. It's very difficult to keep track, even in one's own writing, what is supposed to be in parallel and so on. Here, every single time, even when there are page interruptions and things of the kind, everything is just right. I close with a couple of notes, and I know that everybody wants to eat lunch. Such is the curse of having the pre-lunch time talk. Scholars in my disciplines getting started with LaTeX, here are some things that you folks watching online might want to consider. First, look into BibLaTeX, and to appease Mr. Carl Berry, I'll mention BibTeX as well. A comprehensive citation and bibliography management system that is capable of being interlinked with a variety of citation managers, including like probably a much higher percentage of persons in my discipline are using rather than LaTeX, Zotero, and also Jabref, which is extremely common, say, among legal scholars. I also recommend Text Studio and other LaTeX-specific graphical writing environments. LaTeX, of course, can be written in any plain text editor. I've seen a few of you folks with your terminals open to Vim or Emacs. Debates on those two can continue after this talk.
No, there is no debate.
Okay. But I'm going to suggest that, especially for a newcomer, a designated environment can help improve efficiency and avoid code errors. And I love Text Studio for about a million options. I've tried a few different software solutions. First, Text Studio is entirely free and open source software, which is great in so many ways. It's all locally installed, integrates neatly with the most recent TechLive installation. It's Qt based, the Qt toolkit for theming. And so in my GNU Linux based setup, I set Qt. Right now I'm in love with Dracula, and I get that sweet vampiric darkness whenever I'm writing, right? Here, all these brownie points, so great. But it also has some great features, like it can predict all of the most common LaTeX commands that I might want to trigger. And it, as somebody who's a relative newcomer, compared to most of the people gathered here, having an autocorrection for some command that I don't trigger very much is just very helpful. Another reason that I love it that I haven't been able to use yet, but this is more of just an announcement of a feature for everyone, because it's quite new to Text Studio, is there's a very easy self-hosted collaborative editing option. So a person doesn't have to rely on a paid proprietary online system, but rather can just install Text Studio, have one's colleague install Text Studio. I think you just need a port forward and to click go, and then it just works. And so that's a really compelling thing to get used to using Text Studio. And then if you want to if you're in a discipline in which people actually collaborate in LaTeX, which I am not, but you can make use of that. I also recommend colleagues look into designated packages for individual languages. So my one colleague I have who uses LaTeX is a Syriacist, and part of why he uses LaTeX is there's this super powerful grand package called Surdo, Syriac formalized Aramaic. So it allows a whole bunch of different typefaces that are specifically written to show Aramaic in ways that people who use Aramaic Syriac expect it to look, right? It enables right to left word handling to just work, and all sorts of other features. See Chapter 13 of the LaTeX Companion for other recommendations for language-specific options, or honestly, just run search queries in CTAN. We heard a talk earlier today about expectations for like tags for search queries for CTAN. CTAN is really good. Like if you just type Hebrew, everything that is package specific to Hebrew will show up, for example, or Japanese, or whatever your non-Latin alphabet language needs might be. Finally, a couple of oddities. First, I'm sure everyone here knows of microtype, but use package microtype I use in everything that I prepare, because I love the elegant automatic things like improved automatic hyphenation, subtle justification changes, and so on. Everything just looks right. It makes it so that any document that a person is preparing looks like it was published by an academic press, except it's just going to your own home printer, which is really quite impressive. Now, for the online crowd, there's a package called Gregorio Tech that is continually updated, and it enables the most powerful and elegant setting of Gregorian chant of which I know. Thank you to all the organizers for this wonderful conference. Now I will take your questions, comments, suggestions, snide remarks, and more. Would you like this? Yeah, okay.
Oh, questions? Oh, right here.
Hi, Max Chonoff. So my question is, like, we all know that LaTeX isn't used that much in the humanities. What's the biggest barrier for that right now? Is it because it's too hard to use, the documentation is poor, or people just aren't aware of it? Like, what should we all be working on to make it more popular there? Because that's our goal, right?
Yeah. Thank you for the question, Max. That's wonderful. You've kind of put me on the spot because I don't want to say anything for the record that I might regret in some way. But maybe the simplest way of thinking about this, of course, is, Steve Jobs is often credited with this idea that he foresaw that people would use kind of forever whatever computing tools it is that they were assigned to use when they were undergraduates. And we live in this word processor bubble for undergraduates that continues through graduate students, that then continues through the entire profession, say of a professional scholar in PhD studies, in publications, and so on. And so I guess the great challenge then is breaking in way earlier than we might think we actually need to. Again, going back to that kind of Jobs idea, right? Put the Mac in every school, put LaTeX in every school.
Yeah, so undergraduate outreach is your recommendation?
Yeah.
Thank
Yes,
you.
it is.
Okay, thanks.
Thanks for a nice talk. You mentioned a couple, I think, two documentation for the beginners in the humanity, which is not so short, blah blah. And so, have you ever considered Learn LaTeX org, which recently launched and will be beneficial even for the people from humanities science?
LearnLaTeX.org?
Yeah.
Okay. Thanks for that. Let's just add that to the record. Yes, go to learnlatech.org.
Did you also use letterings or colored letterings in LaTeX?
Oh, I have not, but if I come across an instance in which I need to do it, I definitely will.
Okay, yeah, I know there are, but the colored versions are a bit hard to set up. So I can provide a zip file or something with all the files in it.
Thank you.
Okay, so should we thank the speaker again? Yeah, in this environment where, let's say we're not as fully conversant with the humanities as we might be, it's quite refreshing to hear a different point of view come in and give us some directions to go in. So thanks so much for your talk. It was really good. And so now it's time for lunch. So of course I will say nothing else except we meet, go for lunch, come back 1:45, enjoy it, and we'll have a good afternoon talk.
Okay.
All right, everybody, lunch is over. Well, unless you brought a little extra back to help get through the afternoon. We have one very important announcement at the end of this session. If you read the fine print on the program, it's open mic time. So there'll be an opportunity for you to vent or congratulate people or offer to host a future TUG meeting. Okay. It's the last session of the last day. I'm reminded of a story that the Physical Society meetings on the last day, the speakers would give their talk, pick up their suitcase, and head for the airport. I hope no one is planning that today. Our first talk by River Temple, and let me grab the introduction here. River Temple is an undergraduate at George Mason University, a biology student minoring in art and visual technology. Her professional focus for this presentation is on the intersection between design and science, asking what research needs to be pushed forward in spaces such as space travel. Typography is not always simply an aesthetic decision, but it is a tool. This will be her first presentation for TUG conferences. And the title, From Neurons to NASA, a brief tour of the brain, font psychology, and implications in space flight missions.
Hi, my name is River Temple. I'm a third-year biology student at George Mason University, and I'm very honored to have the privilege of sharing my research with you all today. I really hope that my project can raise some questions and get you thinking about the role of typography outside of design, because today I would like to talk about typography and space science. So the title of my presentation is From Neurons to NASA, a brief tour of the brain, font psychology, and implications in spaceflight missions. Let's talk a little bit about the brain. The brain is like a factory. It's responsible for pretty much most things that you do, and the way that it works is it contains a massive network of neurons that communicate with each other through electrical and chemical signaling. This is what enables you to remember things, move around, and understand what you're looking at, and all the other good stuff. But in order to do this successfully, the brain has specialized compartmentalization. So each segment of the brain is responsible for unique things, but they all work together to complete tasks. Then there is rapid information processing, and that is how your brain handles a steady feed of information, where it uses your memory centers and context to filter out unnecessary information and predict what is going to happen next. And some of the regions involved in successful reading. This can be quite a large topic, so I've boiled it down to the things that you really need to know. The first step is that your eyes capture information. That can be lights, rough shapes. That gets sent to something called the fusiform gyrus, where that information is analyzed, and depending on how it's interpreted, different modules activate. So for example, if it looks like a face, there's something called the FFA, or the fusiform face area, or if it looks like a character or a letter, the VWFA, or the visual word form area, gets activated, which is more relevant with today's presentation. The gyrus then takes all that information and sends it to your brain's memory centers, like your hippocampus, and the live processing feed gets rapidly interpreted based on everything you've seen or known in order to identify it. This all happens within a span of milliseconds, all the time. So how does space travel impact the brain? Well, the first point that I'd like to look at is something called superimposed cognitive fatigue. Basically, your neural feedback builds up and lags, right? Like a computer. If you have a lot of tasks going on, it's all going to be completed slower. The second point is reduced cerebral perfusion or cerebral hypoxia, which lowers function further due to lack of oxygen. The third point is gravity-induced loss of consciousness, otherwise known as GLOC. I'm sure a lot of us have seen those space movies where an astronaut is in an emergency and they have to get control of their vehicle and they start passing out. That is called GLOC. It is quite literally losing consciousness from gravity. And the last point is neuroplasticity, which is your brain physically rearranging itself, especially more dramatically when it is exposed to different conditions for long periods at a time. And a lot of these might seem pretty negative, but they are really important. These are like your body's armor response to handling all these changes. So you really need these things. So delving a little further into neuroplasticity, some things that can happen are your cerebral spinal fluid volume can change, the central sulcus of the brain can narrow, and the actual matter of your brain itself can shift around. And theoretically, we can assume that this probably affects your reading and comprehension because the anatomy of your brain is physically changing. So here we have some images from the New England Journal of Medicine that showcase 94% of analyzed astronauts from long duration missions had their central sulcus narrow versus only 19% in short duration, and it was usually less noticeable. So the period of time that you're exposed to these conditions does really matter. Talking a little bit more about white matter also, there's something called the arcuate fasciculus, which is a connection for the brain's language centers. You have your inferior longitudinal fasciculus, which is linking to visual processing, and these two work together. So the stronger that they're connected, the better that you can read. And dyslexia is what happens when you have bumps in between them, right? You can think of it like there's a highway between the two. You start at one, the other is your destination. If there's traffic, it takes you longer to get there. Pictured here is the Broca's area and the Wernicke's area. The Broca's area is responsible for language interpretation, and Wernicke's area helps you with language output and understanding. So how exactly do you get reading out of this? Well, words are first broken down into something called phonemes. Phonemes are the combination of letters that form distinct sounds in words, like the letter S and H creating the sound sh. Sh, in that case, would be a phoneme. These phonemes are assembled to reconstruct word phonology in the left inferior frontal cortex, but the letters themselves are actually converted into phonemes in the left supramarginal gyrus. Basically, all you need to know about this is it's bidirectional, so it flows between the two to help you both understand language and produce spoken language yourself. Now, how are fonts registered by the brain? A lot of studies use something called ERPs to analyze how your brain responds to things. So ERPs are these little nodes that are placed around your head, and they measure the voltage and polarity of your brain when you are reacting to stimuli. So in this case, it's written stimuli. It just shows how fast it takes you to do things and where they happen. And font disfluency is the subjective difficulty of understanding text within a particular font, right? So a font that's in cursive and calligraphy is harder to read than a standard sans serif font. Manipulating these fonts has actually been proven to slow down ERPs. So essentially we've gathered that fonts that look less like what we're used to in terms of characters do physically take us longer to read, which is important because soon we're going to be talking about how fonts and design and typography goes outside of just aesthetics. So first, let's delve a little bit more into font psychology. Fonts are very intentionally designed, right? Font design, it's an art form. One of the biggest driving forces behind art is emotional representation, and this is not any different from that. Think about if you were to see like a super geometric sans serif font that's using a lot of angles in the character design. You're probably going to look at that and assume that it's technical, modern, and maybe even futuristic. And, well, why is that? A lot of it is cultural association over time. It's led to our brain interpreting certain design choices with themes, feelings, and even places, and that's what makes company branding so successful. If you can get a customer to associate a font with your brand, you immediately have a memorable experience, right? That recognition really matters. And in the bottom right here, we have the Open Dyslexic font. This font is designed to be more bottom heavy, right? So that characters that mirror each other are easier to discern. So if you look at lowercase b and lowercase d, you'll see that the lowercase d does have that extended line And even just small differences like that can help your brain interpret it faster if you have something like dyslexia. Now, NASA's history with typography is pretty cool. The first example here is Futura. It is a sans serif font that was created during the Bauhaus time. It has been used for a lot of different things, entertainment, political campaigns even, and it's associated with modernity and progression. It was coined the type of today and tomorrow. And NASA has used it here in this example on the top left. This is a replica of the plaque left on the moon by the crew of the Apollo 17. This specific piece was transferred by NASA to the National Air and Space Museum in 1975, so it's been there for a hot minute. It's really cool. The second image is the Challenger space shuttle, which is using Helvetica. Helvetica being a sans serif font named from where it was created in Switzerland in 1957. It's very balanced. The lines going both directions are very even and clean, very legible, and it is used also for signage and things like that. The examples that I talk about here come from the brand guidelines. I believe these guidelines are specifically from 2024. However, some examples were harder to find on the actual website, but I'm going to go over them anyway. So Inter, the first example here, was released in August of 2017 by Figma employee Rasmus Andersen. It was designed for computer interfaces initially, and now it's used for marketing and signage. It has this like tall X height, so it's really easy to read even at smaller sizes. Public Sans was based on Lieber Franklin, and this was actually developed by the government for government-friendly branding by the US Web Design System team. This was released in 2019, and it's supposed to be neutral and clear. DM Mono is a monospace sans serif font by the Colvin Foundry. It's for like code, technical labeling, and like numerical clarity. So, you know, all the like number stuff. And this specific listing, like I said, is from 2024, which does also include some information on the legacy typefaces like Helvetica and Futura, but the three that I went over are the ones that are most commonly seen, and then you also have Arial present there. The information on this slide is really cool. It comes from a NASA display standard manual for uniform UI design across interfaces on spaceflight programs. So they want everything to look really clean, and they want to have this like guideline for how you design these things, right, for usability. So some rules here are that the text has to be sans serif, and you have to be able to tell what each character is super easily. It needs to be a fixed width font for numerical and tabular information, just to keep things technically clean and modern. The character height needs to be easily legible, and colors are used symbolically to tell the crew members what the information means. So red is for highest alert, yellow is secondary caution, blue is advisory information, gray is if your information is temporarily unavailable, and cyan is if it's completely missing or stale. And another interesting fact here is there's also a rule stipulating flashing text for immediate crew attention. It's reserved purely for that. And for standard frequency, it's 0.8 hertz, and for super high priority, it's 3 hertz. But the super high priority stuff needs to alternate between 3 hertz and 0.8, because if it's just super fast all the time, it's going to be really hard to read. It's quite an in-depth manual, and it really makes you think about the usability factors of these UI interfaces. Some things to consider is that astronauts really need clarity on whatever they're reading, right? They have a lot to do in not a lot of time, and it's really serious stuff a lot of the time. You know, as fun as it is to go up there and just look at the planet from miles away, you're a very responsible person. So font is really not just an aesthetic choice. It becomes a tool in your arsenal. And when you consider how the brain changes in these conditions, whether it be stress or the time constraints or just, you know, even being in different gravity, it all slows down your neural feedback, like we'd mentioned earlier. So you really need to think about the design choices that you're making here. Some future things that I'd like to explore in this topic. The main one would be if the open dyslexic font is beneficial or relevant for emergency UI on space missions. Right? If it was designed specifically for comprehension and discernibility between characters, in a situation where time really matters and you may not have a lot of it, the faster you can read something to get it done, the better. And I would also like to explore further on how these different gravitational conditions, whether it be macro gravitational like centrifugation or micro gravitational in space, or when you return back to Earth and, you know, that neuroplasticity, your brain changes every step of the way. I'd like to look more truly into how that works. How does it affect reading, and for how long do these effects last? And also, how could the world work together to curate fonts intended for spaceflight that represent larger populations? Could this be a discussion for different characters, you know, like Arabic or other script languages? And can we find a perfect solution for design and apply it internationally as a standard for legibility? I would like to thank Jennifer Claudio. None of this would be possible without her. She saw something in me and gave me this wonderful opportunity to really delve headfirst into something that I ended up becoming very passionate about. And I'm super excited to see what else is in the works for this project. And I'd also like to say thank you to Stephen West, who is someone from my personal life. He was my soundboard for a lot of my research to make sure that I wasn't just saying a bunch of science jargon and it was actually, you know, legible and made sense to a large population. And sometimes I just need that. So that's been really awesome. Thank you for your time.
Interested in the cognitive aspects of perception and reading. And I've noticed in your talk the same kind of trend that we observed in the general literature, which is that nowadays most of the activity involving the cognitive aspects of reading are focused on font shapes and not so much on text as a whole. So I was wondering if you are also interested in studying the impact of not of fonts themselves, but on the arrangement of text on pages. For instance, what about interline dimensions, whether justification is a good thing or whether a ragged disposition would be preferable for astronauts and stuff like that. So everything not involving the shape of characters themselves. Thank you.
I think that's a very interesting question. And honestly, I started kind of thinking about that myself during this presentation, but you are completely right. A lot of the research on how font is read is definitely on font disfluency. I do find it very interesting. I didn't get to delve into it too much given the focus of the content that I was finding and the research that was like pretty available to me for my topic, but that's definitely something that I'd like to look into more. And I do think that that is an underrepresented aspect of the discussion.
Okay, now, thank you. This is not from, okay, this is Boris Weissman. It's not from the chat, it's from me. As usual, I have a question and a very short remark. My question is this. You mentioned colors, red, yellow, and so on. A lot of people have color blindness, actually, considered, and we have now standards about colors, luminosity, and so on. And I have an impression that the NASA guidelines have been written before the research have been done or used. So do you have any comment or any intention to go into the color choices by NASA and whether it's optimal and whether they should change it because a lot of people just don't see the colors like they think they see.
I also thought about that myself because I am slightly colorblind myself. And you're right, it's definitely something that I don't think was considered when the manual was written. I think it might have to do possibly with eyesight requirement standards. I didn't look too much into it yet, but I do believe that there are certain rules that you have to like have criteria wise for your vision to be able to go on these missions.
And I definitely want to look further into any policies regarding regulation on color blindness. But if there is more openness in that area during space travel, I absolutely think that there needs to be more consideration for inclusivity within the colorblind community and changing, even if it's just putting a little comment under or using symbols instead, something that could be understood by everyone. That's a really good question.
Yes, thank you. Maybe we should talk offline about this. And a very short remark, great presentation, thank you. And when you go to last slide, I understood that you are a student of Jennifer Claudio. Many people here know Jennifer. She had been in many TUG meetings, and I just want to shout out to her. She is always welcome, and her students are always welcome in this community.
Yeah, Jennifer is awesome. Definitely shout out to her. I mean, none of this would have been possible if it wasn't for her reaching out to me and inviting me to this whole conference.
And then, like, for everyone who doesn't know, Jennifer was the one who drew this logo on all our t-shirts and mugs and such, so that was her.
Thank you. This is Carl. Thank you, River. It was a great presentation. And I wanted to just say there's a lot of other dyslexic attempts at font designs to help dyslexics nowadays. And seeing a comparison between Open Dyslexic and some of the others could be interesting. And I wondered, for you, is this an area that you're going to be able to pursue in your academics going forward, or are you on to other things?
I would love to. I think right now, given that I'm still an undergraduate student, it's just completely going to be on who wants to be in the master's program, because there's a lot of different things that I'd like to pursue, but this topic is definitely near and dear to me.
Sorry for grabbing mic again, but it just happens that I'm a professor at the same university that River is undergrad, so I need to think about this myself as well.
I was going to ask whether or not you knew her.
It's the first time I see you.
Okay. If there are no more questions, oh, there it is.
Yes.
All right. Here's the.
I actually have a short remark. Watch and learn, Boris. No, I'm just kidding. I am glad that I'm not the only undergrad student here. I'm very happy to see that, and also a very unique presentation. Thank you, River.
Thank you to everyone who took time out of their day to hear me talk about this today. And it's super awesome that there's other undergraduates. I think this is a great opportunity for really everybody.
Okay. All right. If that's all, let's thank River. And on for our next presentation is.
And then we need about 5 minutes.
You need 5 minutes.
Yeah, so 2:50 we'll start it.
Okay. I was going to tap dance, but the floor is too soft. Okay, our second speaker in this last push to completion, Tristan Miller, is an assistant professor of computer science at the University of Manitoba. So not as far away as Toronto, but his research interests include natural language processing, computational linguistics, and all sorts of wonderful things. And he's going to tell us something very important, preparing those grant applications. For those of you still active in academia, very important.
Okay, thank you very much. So, who here is in academia and has prepared grant applications? Okay, a lot of you. But I know from speaking to some of you, we have some people here who are not in academia, maybe not really familiar with how the system works, or maybe you're from a country that does things differently from how Canada does it. And I've only been here for a couple of years, so I'm sort of getting to grips with the Canadian funding system myself. I'm going to be talking a bit about one particular grant application for one particular kind of program. Okay, so just a quick overview about research funding in Canada. It's really dominated by the big three. They're called the tri-agencies, and that is the Natural Sciences and Engineering Research Council, which funds science, technology, engineering type stuff. We have the Social Sciences and Humanities Research Council, which funds all the social science and humanities stuff. And then we have the Canadian Institutes of Health Research, which is all about health and medicine. And like I said, these are basically the three biggest. They're federal agencies. They're the most prestigious. If you're a university researcher, then you're sort of expected to get one of these a grant from one of these agencies if you want any hope of promotion or tenure or whatever. They've been around for a long time, probably about as long as I've been alive. And so, but like I said, I've only been working here for a couple of years, so I don't have too much experience with it. People have written about the history of these funding agencies. Apparently, back when they first began in the late 70s and early 80s, there was a sort of golden age where there was more funding available than there were applicants. And so basically, if you submitted an application for those first few years, it was judged on its merits in isolation and not with respect to any other application that might be received. So the funding decisions were always binary. Either you got the funding or you didn't. I guess a lot of people liked it that way. But starting in 1982, the number of applicants began outstripping the amount of available funding. So they had to move to a competitive model. And it's been like that ever since. So now all these proposals are judged based on merit, and merit is basically judged by comparing you to all the other proposals, and your proposals have basically ballooned into these very lengthy, complicated monstrosities. So, like I said, a lot has been written about it, in blogs, but also in academia. People actually study research funding as a topic of research. Sort of, I don't know how they get funding for that, but anyway. So here's a quote from one study from Michelle McGinn, who's actually in this study it's sort of a self-reflection type study. It's a co-authored paper where they talk about the experiences in applying for funding. So they write, the process of applying for funding is too much like an endurance test or a guessing game. It requires considerable time, commitment, teamwork, planning, and sacrifice undertaken with the knowledge that the result may be nothing but frustration. Probably some of you can sympathize. I imagine that this is not unique to Canadian federal funding. Okay, so I'm going to be talking in particular about Insight Grants. This is the flagship program from SSHRC, as you recall, which funds all the social sciences and humanities research. It's the flagship program. It's the most prestigious SSHRC grant that you can get. You get the most money for it, provided you're successful. So applicants tend to be not necessarily individuals, though nothing stops you from applying as an individual. I think it's more common that the applicants would be small teams of researchers. All applications nowadays are submitted, they have to be submitted through a web-based portal, okay? They did away with paper applications already in the 90s. They moved to some sort of MS-DOS-based system, and now it's all on the web, okay? So what does this application form involve? Well, it involves dozens and dozens of short answer form fields. There's in fact lots of, probably hundreds or thousands of short answer form fields you need to type your CV into, which is lots of fun and can take several days. There's also between 1 and 3 long answer form fields. Basically, you know, you type an entire page's worth of text into it. I don't know exactly why, because there's lots of other places on the form where they actually ask you to attach a PDF that can also be a page long or sometimes several pages long. Okay, so just to give you some idea of what it looks like, so the Insight Grants call for this year is now out. This is a screenshot of the first form in the application form. You can see here on the left, those are all the different categories of forms that you may need to fill in. Some of them are mandatory, some of them are optional, depending on exactly what you're proposing. This little white mark beside those categories, that indicates that a PDF attachment is required for those ones, and possibly also some of these forms. So you see here a bunch of short answer forms where you actually type in a short answer, or maybe here or here select things from a list, okay? Then we have, I'm zooming in here to one of the categories that has this little symbol here. This is what it looks like when you need to attach a PDF. So you get this sort of instructions with specifications. As far as I know, almost all the specifications are usually all about the same, and then you just attach a file here. And then finally we have, like I said, some of these forms are actually long answer forms where you basically need to type a large amount of text or paste a large amount of text into this online form. And you can see here, there's a character limit. Okay, so the challenges in filling in one of these things, besides the intellectual challenge of coming up with a good research idea. Oh, my time is off. So applicants need to make sure that they adhere to all the content and structure and formatting requirements, okay? They need to also make sure that all of this content and formatting is consistent across all those different form fields, again, some of which you type in directly into the web, some of which are PDFs. And so that means if you're writing it offline, as most people do, you need to make sure that your proposal is consistent across all those different areas that you're going to be uploading individually or typing into the form individually. Because writing a proposal is, you know, a very long process. It takes a lot of time. People usually invest months and months. You've got to make sure that you keep all that stuff consistent across different revisions that you may be making. And of course, since you may be collaborating with a team instead of doing it on your own, you need to make sure that all your co-authors are on the same page and that you're all using the same formatting and style and that sort of thing. And of course, like I said, because most people are not entering their data directly into the web form, you need to take whatever workflow you're using, whether that's, you know, typing stuff into Microsoft Word or LaTeX, as we will see, and make sure that whatever you do is going to be, you know, submittable on the online system. So those are the main challenges here, okay? So what I'm presenting here is something called SSHRC Insight. And this is a LaTeX package that I've developed specifically for Insight Grant proposals. So the goals of this, which basically match all the challenges on the previous slide. Number one, we want to automate the formatting, especially of the PDFs, so that they meet the SSHRC mandated specifications. We want to ensure that they are consistent with each other in terms of style and in terms of things like citations and cross-references. As we all know, LaTeX can only output one PDF at a time. So you can't just put your entire proposal into one document and expect it to spit out, you know, 10 different PDFs all with the same citation numbering. Or can you? We'll find out. We also want, of course, in doing this, of course, I like writing everything in LaTeX. So I want to support my own familiar LaTeX document processing workflows, which involve things like, writing in my text editor of choice, using my versioning control system of choice, that sort of thing. And of course, even though I want to support all that, I also want to make sure it's compatible with the online system. So no matter how I end up authoring the proposal, I need to make sure that it ends up spitting out all the data that I can directly import into that form without too much trouble. Okay, so what is the purpose of this talk right here? Well, if there happen to be any humanities researchers here from Canada, or who might want to submit to Canada, to a Canadian funding agency, well, I'm going to describe the functionality of this package, so it might be useful for you in that sense. But probably most of the people here are a bit comfortable doing at least a little bit of development work in LaTeX, so hopefully this will sort of serve as an inspiration to all of you to maybe build similar proposal templates and packages of your own for meeting, whatever requirements of whatever funding agencies you normally apply to, okay? And of course, we can discuss my design as well. I mean, I make no promise that what I've come up with is the best possible solution. And so if you see a better way of doing things, please let me know during the discussion period or send me an email or whatever. Okay, so this work isn't without precedent. A couple of years ago, I wrote a similar funding, like a LaTeX package for Horizon Europe, because I was in Europe until a couple of years ago. So Horizon Europe is the European Commission's basically largest and most prestigious research funding program. It funds, work in the social sciences, humanities, medicine, I think, also natural sciences. It basically does everything. It's huge. So it's got many different types of funding programs, individual ones. I wrote a package for handling research and innovation actions, or innovation actions. And so the comparison between these two packages in terms of what problems are they trying to solve? Well, for an Insight grant, you generally need to submit somewhere between 7 and 12 PDFs to the online system. But for a Horizon Year proposal, it can vary according to the program, but at least for the ones I've done, you need only one PDF. So this enforcing consistency across PDFs, that's not really a big problem. So we have a new problem here with Insight grants. The Insight grants tend to be, much shorter than the Horizon Europe ones. So maybe somewhere on the order of 50 to 100 pages, whereas research and innovation actions, they can balloon to many, many hundreds of pages. So that also sort of affects where you need to concentrate. Of course, in both cases, you need to follow all the funding agencies' formatting and structural and content requirements. You need to make sure that you're maintaining consistency of the style and content and whatnot across revisions. Managing multiple co-authors, and of course, because there's only one PDF for the Horizon Europe ones, we don't really care about maintaining consistency across PDFs. The online forums for the Horizon Europe, they don't have as many long answer forms, and the ones that do are really not so onerous, so we don't really care about maintaining consistencies between the PDF and the online form. But one thing that you really need with the Horizon Europe proposals that you don't need with SSHRC is calculating all kinds of tables. Basically, this one PDF you do, you need to put all the data for the proposal in it, including the budget and the individual collaborators need to be numbered, and you've got to refer to those numbers later in the proposal, and you need to add up individual columns of the budget and whatnot. So basically, you need to have you either maintain a separate spreadsheet and laboriously copy all the information into your proposal, and you redo that every time your budget changes, or every time you add a new partner and need to do the renumbering, or you do it programmatically in LaTeX and let it do all the calculations for you. Okay, so that's why basically why I wrote this Horizon Europe template, is to eliminate all that problem. But we don't have this problem with Insight grants, fortunately. Okay, I'm not the first person to have tried to come up with some sort of LaTeX or automatable solution for Insight grants. About 10 years ago, a fellow named Christopher Barrington Lay, posted on his blog a Python script that he uses for SSHRC Insight Grants. But he doesn't use LaTeX directly, he uses LaTeX. But LaTeX can be exported to LaTeX, which is what he does. So his Python script basically, he writes the entire proposal in a single LaTeX document. Then this Python script takes that LaTeX document, converts it to LaTeX. It counts all of the characters in the long answer form fields, and then makes sure that they're don't exceed that character count. It exports them to a text file that he can then copy and paste into the online form. The rest of the LaTeX proposal, he compiles into this one unified PDF, and then he uses some sort of a PDF processing program. I don't remember which one, maybe it's just Python itself, that splits that PDF file up into separate files that he can then upload into the correct sections of the form. So that script is in principle adaptable, maybe even to LaTeX, I'm not sure. It's not really designed for LaTeX, it's designed for LaTeX. But he doesn't really provide any sort of document template, so there's no provision for managing the content or structure or formatting. You just got to figure that part out on your own. The documentation is pretty sparse. It's basically 10 commented lines at the beginning of the Python script. It assumes familiarity with Python, which might not be true for every social sciences and humanities researcher. I mean, we can say the same thing about LaTeX, but at least with LaTeX, there are some nice user-friendly interfaces, right? Maybe not so much for Python. That script also, I mean, it's obviously, it's just sort of a kludge that he uses for his own personal use. He didn't really polish it up for publication. So all the file name paths and system calls and the page ranges and everything, those are all hard-coded, okay? And I don't think he's actually maintained this. I think that was just this one blog post 10 years ago and it's never been updated. Okay, so what am I doing? Okay, well, let's go through some of the technical challenges and the solutions one at a time. So again, another quote here. So team members had different style preferences, but coherence demanded a consistent style. Should we or should we not use serial commas? How about digital object identifiers, DOIs? The principal investigator declared me the technical wizard because I could put asterisks in the margin next to SSHRC-funded entries on our respective CVs. That's one of the requirements. Now, keep in mind that she's actually writing about presumably a word processor-based workflow, right? Not mine. So the good news is that SSHRC's document-level formatting requirements are pretty simple. We saw them on one of those screenshots. It's just basically margins, paper size, and font. That's it. So that's no problem. So SSHRC Insight, just in a few lines of code, and I'm not even going to show you what it is. You guys all know the geometry package and whatnot, how to set fonts and things like font spec. It automatically applies all that mandatory styling, okay? And my package basically lets authors use whatever other styling rules they want, because SSHRC gives you wide latitude to format your proposal how you want, subject to those mandatory minimum styling requirements. And of course, if you're writing your proposal in LaTeX, this is based mostly on semantic markup, right? So if you just stick to the regular, section, subsection, footnote, whatever macros, everything's going to look the same. It's a lot easier to deviate from that when you're using a word processor, right? You've got to sort of force yourself to use that style drop-down menu, and of course, we've all worked, with co-authors maybe who weren't aware of that or forgot or whatever. Okay, so it's much easier to enforce consistency that way. Also with bibliography, of course, we have style files for BibTeX or BibLaTeX that we just enter all the information about a publication and it takes care of the formatting. So we don't need to decide collectively on whether or not to use DOIs, right? We just pick a bibliography style and the program takes care of it. So this has nothing to do with SSHRC Insight, it's just a consequence of using the standard LaTeX tools. So SSHRC doesn't care what referencing style you use for the references, for the bibliography, that's fine. It just imposes 2 additional requirements. Number 1, any work that was funded by SSHRC needs to have an asterisk in the margin. That's what we saw in that quote. And student authors in any reference need to be annotated with a plus sign, okay? Now, applying this formatting has befuddled a lot of grant writers. Again, we saw that in the quote, but it befuddled even me using LaTeX. I didn't know how to put a star in the margin next to a bibliography entry. Okay, but I look it up once, I put it in a package and put it for make it available for everybody else to download and use. Okay, then nobody else needs to know, right? So I provide these ready-made solutions, provided the authors are using BibLaTeX. I do know how to do it in BibTeX now, but BibTeX is a lot harder to customize. You need to apply that to every individual style you use, whereas BibLaTeX sort of divorces those kind of annotations from whatever style you might want to apply. So for annotating SSHRC-funded works, we just add a keyword to the bibliography entry. And then SSHRC Insight package takes care of the rest. All we have to do then, all it does is it changes this begin entry bib macro for BibLaTeX, adds a box of 0 width containing an asterisk. So if you're a developer, simple solution. If you're a user, ooh, it's magic. So here's an example. So we just have, a standard, BibTeX entry here, and the only weird thing about it is that it has this keyword here, and when we process it through, Beaver and BibLaTeX, it ends up putting this nice star in the margin, exactly like the specifications. Similarly, annotating student authors, I didn't really have to do anything myself. This is something that BibLaTeX handles natively, and it's there for anyone who bothers to read the 700-page manual. There's something in BibLaTeX called a data annotation. So what you can do is add this field to the BibTeX entry, or a field in this format, author plus AN, and then you just basically write the index of the author in the author list, followed by equals, and then you have some sort of special keyword, and then you can, change your class so that it applies some special formatting for any entries with that keyword. So that's exactly what I did. Actually, I don't think I've shown the code here. Yeah, okay. But this is basically how it works. So you have some other BibTeX entry with a list of 3 authors. So you just add this extra field here saying author number 1 and author number 3 are both students. And then when you compile that document, oh, there you go. There's the plus sign, exactly per the spec. Okay, what other technical challenges do we have? Okay, let's go back to Michelle McGinn. What else does she complain about, she and her co-authors? Okay, any change in one section had ripple effects across other sections, and we had to check carefully to avoid any inconsistencies. When we added or removed research components or shifted items from one budget year to another, we had to ensure the proposal, the budget, the description of student training, the knowledge mobilization plan, and all other sections were aligned. Okay? And keep in mind that you're doing this on a proposal that is split across multiple documents. Barrington Lay wrote, for the 2015 SSHRC Insight Grant, there are 2 of the big text entry boxes and 7 separate PDF sections to upload. One of those is a list of references. I would like to use a citation manager to make citations across the various PDF sections and to have the reference list coordinated across them. I would like to prepare everything in one file when I'm writing or sharing drafts for comments. Okay, so this brings us to solving basically the major problem here. How do we get multiple PDF files out of one document? Because if you recall, the proposal needs to be submitted as a combination of separate form fields and PDF attachments. But when you're writing a proposal, that's really annoying to work on multiple documents and keep everything consistent. Everyone wants to work on the proposal in one document, right? So what I found was a package called subfiles. There's a package called subfiles that allows you to, if you use it right, you can easily switch your compilation modes between compiling individual documents or compiling one document that includes all of them. And the nice thing about that, it's not just including existing PDFs, it's actually handling things like making sure the citation numbering is consistent, as we're going to see. So how you have to apply this with SSHRC Insight is when you write your proposal, every proposal needs to have a main file, and we could call it, say, proposal.tech. That file needs to have document class SSHRC Insight. And then it needs to include every subfile, that is every PDF or whatever that you want to upload separately or copy into the form using the subfile command. And if you compile that main file, that gives you your complete proposal, everything that you're about to submit. Each subfile is one of those separate documents. It needs to have the subfiles document class, and you need to give it this optional argument, which is the file name without the extension of your main file. Now, these subfiles will automatically inherit the main file's preamble. So for example, you need to put only your styling information only in the main file, your bibliography setup only in the main file. Okay? And if you compile any one of those subfiles, you get one of those individually submitted PDFs. So here's an example of what the proposal, the main proposal file looks like. We do this. I've actually added a little optional argument here because you can specify what year's specification you are aiming for, because SSHRC might change the requirements from year to year. You basically just, you can add your bibliography stuff here, give a title to your proposal, and then you just have a whole bunch of these subfiles, each corresponding to what you saw on that screenshot before. And then of course the individual subfiles, document class subfiles, and then you just write whatever you want for that one PDF. And notice here, even though this subfile is for the list of references, we don't need to include any of this bib LaTeX stuff, because that was all in the main file. It gets automatically inherited. Okay, so how do we ensure that the citation numbering is stable no matter whether a subfile is compiled individually or a part of the main file? Okay, you can imagine that if your proposal has 100 citations, but maybe one given subfile of it cites only 5 of them, you don't want those 5 to be numbered 1, 2, 3, 4, 5 in the subfile. You want it to use the numbering of everything, because you have only one file in the entire proposal that is supposed to list all of your references. So the solution is basically to force all the subfiles to use the BBL file of the main file. And SSHRC Insight handles that entirely transparently by basically conditionally loading the bib LaTeX read BBL package. It's just a package that basically forces one document to use a different document's BBL file. The only weird thing going on here that you need to watch out for is that you need to compile the main file before you compile the subfiles. Otherwise, they won't have bibliographies. Oh, I'm running out of time, aren't I? Okay, better go quick. Okay, so another problem is you might have broken hyperlinks in your document if you're just compiling one subfile, because it might, you might link to some section or some bibliography entry that's in another file. So the package just takes care of automatically disabling hyperlinks if you happen to use hyperref when you're compiling a subfile. For those form fields that you need to type in on your own rather than as PDFs, the class provides a count characters macro where you can just type in plain text as the argument whatever it is that you want to type into the form field. And of course the advantage though is that when you compile the main document, you actually get to see that. It's not hidden in the web form only. Okay, so here's an example of that count characters, and that you basically just type in the text that you want to type into the form. It counts the number of characters and warns you also if you're over the limit. When it comes time to submit, you can just copy and paste that into the form. Okay, I think I'll need to skip a little bit because these slides basically just talk about the benefits of working with LaTeX and version control in general, which I'm sure you're all familiar with. McGinn was documenting an experience where she had 4 collaborators and was working on this proposal for 3 months, presumably in a word processor, and had to manage 206 different drafts from different collaborators and manually merge them. But of course, we don't need to worry about that when we're using something like Git and LaTeX or Overleaf or whatnot. It handles all that for us. Okay, so just to conclude, is what I've done a waste of time, or is this actually going to be useful? Because does anybody in the humanities or social sciences actually use LaTeX? But I think there is good evidence, and we've all seen it today, at least with Corey's talk, that yes, there are humanities researchers that use LaTeX. I don't know if anybody knows, but a past president of TUG, Christina Thiel, was a linguist and used tech extensively. She actually even authored a Tech in the Humanities column for Tugboat for a while. I think it's no longer written though. And so Thiel argues that we tech developers, or people who develop tech packages, we should concentrate on reducing the learning curve for non-tech users and make it user-friendly for them. And I think we're at a point right now where we can greatly succeed. It's just a question of let's write these packages. Let's get people interested in it. I've had some great experiences doing it. I've submitted a few proposals using these packages, one of which was actually accepted. So it actually works. And I actually have collaborators in the humanities and social sciences. I'm a computer scientist myself, and they did not balk at all at using technologies like Overleaf and whatnot in order to help write the proposal. So I think it was a big success. So thank you very much. Yeah.
All right, time for questions. I can see everyone's ready.
Does it come with a guarantee of success in the competition?
No, but I mean, if you do get something funded, then I'll take a commission.
The question is a little bit more about this subfiles package. Can it compile the whole document and change the options or the options for the document class?
Change the options for the document class.
I'll give a concrete example. Can you, for example, just my idea is to compile the same document with sometimes different options. For example, draft and non-draft, and doing it automatically without me keying in the draft option.
You might be able to do that. I'm not sure.
Okay.
You'd have to read the documentation for that one. Okay.
Yeah, both, okay. Are you planning on creating one of these packages for NSERC proposals? Please.
I'll probably write an NSERC proposal at some point in the near future. So probably yes. But let me work on my SHRC proposal first now that I have it. Yeah.
Yeah, Frankie. Just a quick question. Getting everything in one file while working, I fully agree with you. That's very helpful. But why didn't you consider just sort of taking an offside step and split the PDF in the end and make it that way?
Well, there's a few hiccups if you do it that way. So, for example, that breaks the hyperlinks. If you
Well,
do it that
depends
way.
on how you do it, I guess. But yeah, probably.
Well, I don't think there's any. There's no PDF splitter I know of that does that intelligently. That will preserve maybe. Well, yeah.
Okay. Yeah. I was just interested why not. So that's a good argument if you have
Well,
hyperlinks
another reason why
inside.
not is you don't necessarily know in advance where to split the PDFs. Because they might have varying number of pages.
System could
so
tell
remember
you
the
that.
Python script that I talked about, he hard-coded them because he couldn't figure them out programmatically. But with subfiles, you just need to know the name of the file. In fact, you can put them all in a make file if you know, or whatever, some sort of automated build system if you don't want to build them all separately.
Yeah, sure. Thanks.
You mentioned that you now can basically write all of the content in basically one document or split across a few files.
Yeah.
Could you then actually go one step further and just programmatically submit that through whatever API the web form uses?
Programmatically submit this. Okay, I'm glad you brought that up because in the, like I said, the whole research funding and application process is itself the object of scientific study. And one of these studies makes the case that the application process is complicated on purpose. It's basically put there as a barrier so that they don't get so many applications. It's basically a filter. So they don't want it to be made easier. So even if I were able to do that, I think the funding agency would see, okay, I've opened the floodgates, we're going to change things so that it doesn't work anymore. Yeah.
Thanks.
Since you mentioned these was for the SSHRC proposals, which are for humanities, I believe, and from the last presentations, we heard that humanities aren't necessarily like LaTeX isn't as popular in those areas. Have you heard from users like common issues that they've had or things that would make it easier for them to like onboard onto LaTeX?
Yeah, if you read the paper that I cite on this HERIA class, I did sort of my own sort of post-mortem case study on the proposal that I wrote with it with about 20 other co-applicants, some of which were in this social sciences and humanities. And I gathered comments from them and feedback. So that's all summarized in there. Yeah, there we go. So it's this one right here. This appeared in Tugboat, right? Yeah, a couple of years ago. And I will submit a Tugboat article on this talk, hopefully, within a week or two. Yeah.
Oh, which way is it? Is this way? Yeah, okay. Hi, yeah, Arash here. I think that's my name anyway. So one thing I was curious about from like an accessibility perspective is, because I've been applying for a lot of these grants, and I'm not in humanities, but yeah, for the STEM grants, like I was doing some for this research proposal that was accepted. It wanted a few of them, and so my question is, when the thing I struggle with the most, I think, is like they want certain things formatted a certain way and structured a certain way, and this has to be bold and that has to be aligned, and you need to check for this. Do you think from that like accessibility perspective, because obviously I can't do it easily, like I can do it in Word, but no one wants to do that. And also I can't easily see. Well, I can't easily see at all, period. But also in this case, I can't see the rendered form. So, working in like using your package, do you think that would kind of lower that barrier a little bit from an accessibility perspective?
Well, I imagine it would, because you're going to be using here only semantic markup, and you're going to be entering all the information using a text-based interface. So you don't really need to see what's on the screen. You just need to know the content of it and how many pages it renders to make sure you're under the page limit. SSHRC Insight Grants, like I said, they don't impose onerous formatting requirements, at least not to the extent that, for example, Horizon Europe ones do. So you're already sort of in the clear most of the way anyway.
Sorry, as a follow-up. So for academics, do you see this as specifically just for grants or other academic things as well? Because like you just mentioned that there aren't that many formatting constraints with grants, but where I see them more in academia is writing things like essays or applying for certain things and certain opportunities in academia. You got to write essays. Do you think it's something that you could use there? This package?
No, this is really built to solve one particular problem, and you couldn't even use this, for example, for a different funding program from the same agency, because the requirements are going to be, too different.
Yeah. All right, thank you. Let's thank our speaker.
Yeah. And again, if anyone has any suggestions on how I can improve things, get in touch with me.